Hola, ¿qué tal? Buenos días a todos. Soy José Luis Bueno, el director técnico de la Biblioteca Nacional, y voy a hablar solo muy brevemente para dar a todos los que estáis aquí, a los que nos siguen en streaming, la bienvenida a estas segundas jornadas de inteligencia artificial. Estamos muy contentos de que se celebren estas jornadas. Nos parece que es un buen síntoma para la biblioteca que podamos estar tan pendientes y tengamos oportunidades para compartir experiencias, para aprender, para pensar juntos sobre el impacto que tiene la inteligencia artificial en el trabajo de las bibliotecas. Es evidente que es uno de los grandes temas del momento, que está impactando en la sociedad, y las bibliotecas, como parte de la sociedad, pues sufrimos el impacto nosotros, y también tenemos que estar atentos, alertas y escuchando cómo impacta la sociedad, porque lo hace de muchas maneras, en cómo se crea el contenido, en cómo se conserva y en cómo se difunde y en todo, ¿no? Y evidentemente también en cómo nos puede ayudar a nosotros a hacer nuestro trabajo. El año pasado la jornada tenía un carácter, digamos, más estratégico. Teníamos aquí diferentes autoridades, se hablaba un poco de la inteligencia artificial como un proyecto de país y el papel también que las bibliotecas, que la Biblioteca Nacional puede jugar en esa estrategia de inteligencia artificial. Esta mañana tenemos la oportunidad, y quiero agradecer muy especialmente a todos los miembros del grupo de trabajo de inteligencia artificial del CENL, la Conferencia Europea de Bibliotecas Nacionales. Tenemos la oportunidad de contar con todos los miembros de este grupo. Por este motivo, de hecho, la jornada se celebra en inglés, ¿no? Porque queríamos aprovechar que están aquí para que nos contaran cada uno brevemente qué están haciendo, qué están pensando, qué problemas tienen, qué les preocupa, qué han resuelto en cada una de sus bibliotecas. I want to welcome you to the National Library and to thank you for being here and sharing your views, your experience and your concerns about artificial intelligence. We are very proud of having you here. La Biblioteca Nacional también forma parte de este grupo, y confiamos en que sea es para nosotros un foro privilegiado también de aprendizaje, ¿no? Al final, la biblioteca tiene muchas caras, muy próximas a todo el sistema bibliotecario español, pero hay peculiaridades también de Biblioteca Nacional que hacen que un foro como la Conferencia Europea de Bibliotecas Nacionales pues sea importante para nosotros por la proximidad y lo común de muchos de nuestros problemas. Como decía, el año pasado la jornada tenía un carácter más estratégico, este año la jornada tiene un carácter más técnico, precisamente y gracias a esta oportunidad. Tenemos también en la jornada la presencia de Claria, que es la red española de investigación en humanidades digitales, un proyecto europeo, y con los que también organizamos la jornada del año pasado, y que como red, pero también más allá de la red en sí, como investigadores, nos parece también importante, porque desde la biblioteca lo que no queremos perder nunca de vista es el papel que tenemos de apoyo a la investigación, ¿no? Por eso también para nosotros contar con Claria en estos encuentros es importante, y de hecho, al igual que el año pasado, esta tarde se celebra el encuentro Claria, ¿no? Aquí también en la biblioteca, que nos alegra mucho poder acogerlo. Así que sin más, reitero las bienvenidas, reitero las gracias, y doy paso ya a Elena Sánchez Nogales, la jefa del Servicio de Innovación Digital y Reutilización, a la que también quiero agradecer mucho todo el trabajo y esfuerzo que ha hecho para organizar esta jornada. Así que nada, muchas gracias y que disfruten. Hasta luego.
Hola, pues buenos días otra vez a todos y a todas. Gracias, José Luis. A quienes estáis aquí, nos vais a ir acompañando a lo largo del día. Estaremos aquí todo el día hablando de inteligencia artificial, y a los que nos ven desde YouTube, que espero que también sean muchos. Bueno, en esta primera intervención de la jornada hemos querido que sirva para explicar en qué consiste el propio grupo, ¿no? de AI in Libraries de la Conferencia de Bibliotecas Nacionales Europeas, de CENL. Este grupo trabaja para identificar, como sabéis, pues... Okay, thank you.
So again, thank you so much, Elena, and all your colleagues here for your warm welcome during the last 2 days. It has been a pleasure to share our experience with you. A brief introduction, but you already know CNL stands for Conference of European National Librarians, or libraries. It has been established in 1987. So far, we are 46 members all around Europe. I'm just quoting here our motto. We would like to meet and work together and to exchange knowledge, foster professional experience, excellence, and build mutual understanding. So that's exactly what we would like to do within this group, dedicated to artificial intelligence. We start first with our colleagues in Norway and in France. Since 2020, the group has slightly grown. We are now around 20 people working within this group. Since 2020, you probably know the pace of change in our domain has been frenetic. We have seen many changes, so it's still very interesting to share and to experiment within our institution. When we first started in 2020, we were thinking about applying OCR, applying automatic recognition of manuscript. We were also trying to apply computer vision to our collection. Now eyes are very multiple, they are very various, and far more complex than they were in 2020. So it's still a need to promote this sharing and to exchange and to collaborate between all our institutions. 2021, another big shift, the explosion and the operation of large language models and the rise of ChatGPT-like models. So again, this is very important for us at the European scale to train models competent in our own languages. As previously said, a short focus on all our members. This year we have been very pleased to welcome representatives from National Library of Spain, plus much more, many of our colleagues from all over Europe. Very recently we have been asked by our colleagues in Portugal, Law University Library of Coimbra, to join the group. So we are very open to welcome other types of libraries. So what kind of action are we doing? At the very beginning of our activity, we launched a survey regarding the implementation of AI in Europe, in our sector. A new edition of this survey is about to be published. The output will be public for sure. And this survey, this new edition, will include an addendum on generative AI because of the big shift, large shift occurring in 2021. So we are also trying to organize every year multiple series of webinars. We are mainly focusing on techniques, but not only. And this year, most of our webinars have been emphasized on large language models, text-to-speech, automatic cataloging, which are hot topics inside our sector. We are also trying to organize every year a workshop to physically meet in National Library. We first have been hosted by the BNF and this year in Madrid. Yesterday we discussed about our next actions. We are planning to launch another survey on the relationship between us and the private sector regarding AI training, AI reuse of heritage collection. And maybe also we are thinking about proposing to the CNL to work and then to publish a common statement on ethical AI. A short focus on this survey, but more to come and more to be published very soon on our website. It should be noted that a few national libraries are not doing any action on AI, so the orange sector on this graph, and this sector, these figures around, I think, 10 are slightly decreasing every time we are asking our colleagues what they are doing. Another interesting insight question here is: have you already implemented something in your organization formally dedicated to artificial intelligence? And again, the main answer is no, but this no answer is slightly decreasing over a year. And to finish this short introduction to our work, I have also to say to you that we have many other sister initiatives around AI in our sector, particularly IFLA, for sure. IFLA has set up for many years now a special interest group on artificial intelligence, so you are very welcome to participate. And I know, Elena, you're a member of the IT interest group. IFOLAM is an informal, I would say, international initiative. We are sharing with museums, with archives, our concerns about artificial intelligence in our sector. Again, it's a very open organization initiative. You are very welcome to participate to our webinar, to all our action. The IIF International Consortium set up 2 years ago a community group mainly dedicated to machine learning and artificial intelligence. So again, many interesting things occurring within this community group. And LIBOR is also willing to set up something dedicated to AI in the next month. So thank you again. Elena, I think it's up to you to introduce. Thank you.
La próxima parte del programa queremos dedicarla ya, va dedicada a acciones concretas, proyectos, situación de inteligencia artificial en las bibliotecas nacionales de casi todos los miembros de CENL que nos acompañan aquí. Hay un pequeño cambio en el orden del programa que publicamos inicialmente, pero bueno, han sido muy amables de preparar esta presentación y compartir con vosotros, con quienes nos están viendo, qué se está haciendo en sus bibliotecas nacionales, ¿verdad? Que estamos todos deseando ver en concreto en qué se traduce toda esta reflexión estratégica que hemos venido haciendo en el último año y medio. Entonces, escucharemos ahora de nuevo a Jean-Philippe, que se queda para hablarnos de la visión de la Biblioteca Nacional de Francia, a quien miramos mucho desde aquí, y en particular a proyectos de computer vision, visión artificial, aplicando inteligencia artificial a imágenes. Interesantísimo. Después tendremos a Lesser, Roger Nielsen, de Dinamarca, con una presentación breve pero muy interesante sobre speech to text, reconocimiento y transcripción de voz, que como estuvimos ayer hablando en la reunión que tuvimos en el grupo, a día de hoy es de hecho una de las áreas más interesantes, vemos más potencial, nos hemos centrado mucho quizás en texto, pero ahí hay muchísimo potencial por explorar, ¿no? Y vamos a ver proyectos muy relevantes en los próximos tiempos, creemos. Después, Steven Claessens, de Países Bajos, dará una perspectiva general del trabajo en su biblioteca pero se centrará en datasheets for digital cultural heritage, acceso y tratamiento computacional y machine learning con datos derivados de colecciones patrimoniales. Nos interesa muchísimo también aquí, ¿verdad? Miro a mis compañeras que estamos trabajando mucho en esto. Y por último, en este primer bloque nos acompaña Tan Lu, que compartirá estrategia y enfoque sobre inteligencia artificial en la Biblioteca Nacional de Bélgica, que es de donde viene él. Y al final, después de las 4 presentaciones, tendremos unos minutitos para preguntas, ¿vale? Animaos, intentaremos ver si desde YouTube alguien se anima también a trasladar alguna pregunta. So, I was introducing this section of the program. We will be starting with Jean-Philippe and the National Library of France now, and we will have time for some questions at the end of the 4 presentations, okay? Thank you so much again, Jean-Philippe.
So with this presentation, we try to give you a taste of what we are doing at the BNF, but not just at the BNF. I will introduce to you many other projects we have been seeing around us or projects we have been collaborating with regarding application of computer vision to our jobs. First, a very short introduction about the BNF and kind of strategy we are applying for 5 years now at the BNF, and then kind of journey starting from 2015 to today around computer vision in the heritage sector. Very briefly, we have very large collections, very diverse collection. Some of them are full with images, eventually any kind of document types. So AI for us is a tool to have a better access or to better understand and disseminate this large, massive collection. We started to work on AI strategy in 2019. We published this our roadmap, feuille de route, in 2021. And regarding this, the core of this AI roadmap, AI strategy is a multi-year program of experiments. By experiments, we envision local, very small proof of concept prototypes, in-house prototyping, to very large research project like Horizon 2020 European project or French-funded project. We are also very keen to partner with the academic sector, the private sector on this topic. But at the end, we are trying to work not for AI, we are trying to work for users. So we think AI is a tool for us, but also for our users, and mainly for our biggest audience, which is researchers. So we said our data lab, also open in 2021, is a very convenient tool to address these needs. So a few words about before this roadmap. I was mainly focusing on OCR digitization, and around after the deep learning revolution, 2014 in Europe, we thought it was not the only area of interest for us, so we decided to try to work on computer vision, apply not on printed material but on images. So, as said, in 2021 we published this roadmap. I'm not going to dig into it, but it's addressing artificial intelligence as a tool to accelerate our digital shift at all levels. So research, surely, but also training, improving our colleague skills about digital shift, application of artificial intelligence to all our jobs and missions. So it's also implied to massive change in our IT system, in our IT infrastructure, and this multi-year program, I will dig a little bit more later. So on the right side of this slide, you can see the impact of ChatGPT on us. The left side is before ChatGPT, I would say, as a tool, and after ChatGPT and after new kind of interaction between national libraries, big collection holders, and us, we have been pushed by the government, but we also have been asked by the private sector for a better collaboration with them, considering we have massive textual collection, at some point massive speech collection, and so on. We are trying to replicate what we've done so far with researchers, with the private sector. It's for us, I would say for many other languages, cultural landscape in Europe, it's very important for us to promote the use of French and other French variants in such big models. Our program of project, again, it's a complex landscape, but it should be noted that we have designed this work, this program around 5 areas, and there are very classic domains of application of artificial intelligence in our sector, from automatic or aided cataloging to I would say optimization of our decision-making process, optimization of the way we are managing collection, but also buildings at some point. So now the main focus, computer vision, starting from the pioneers, meaning the pioneers of the deep learning revolution, because I was, before 2015, I was quite an important area, technical area for researchers and practitioners. I'm putting here a couple of, I would say, pioneers all around the world, starting with the BNF, with this prototype. In 2017, it was, at least at the BNF, it was the first attempt to apply AI at world scale on top of all type of collections, from newspapers to maps and still images, using both trained model, in-house trained models, and commercial APIs. A sister project at the Library of Congress in 2020, very same techniques applied to only to newspapers illustration. So again, classification, is it a map, is it a comic, is it an ad? Train model and visual similarity search engine. When we are talking about images, we should think also about other kind of images like maps, plans. This, I'm putting here 2 projects. First one, collaboration between the PFL in Lausanne and BNF about semantic segmentation, meaning we would like to apply kind of OCR on top of our maps and plant collection, which the aims here is to extract information from maps, as we are doing for decades with printed material. Very same aim, very same objective from our colleague in UK during the Living with Machine project. One of the aim of this project, very interesting project, was to apply semantic segmentation on top of a large collection of UK maps, meaning, again, extracting railways, roads, network, and so on. During the first area, I've been talking about classification, extraction, segmentation, and most of the time these tasks can be painful. Around 2019, 2020, question was, maybe visual similarity is enough, and maybe it will be simpler for us and for our users to look with this new criteria of similarity. And we have, it should be noticed that many prototypes around this area were trying to address how can we visually search in a very large scale data sets or collection or corpora. One of these pilot projects is Pixplot. Pixplot is still very active. So it means computing a visual signature of every image and letting user browse, navigate into a cloud of images. Another attempt from Oxford University, VGG group. Very similar objective, but here it's very interesting. But this prototype can access very detailed segment of any kind of image, and look for very similar image thanks to this to the detail identified by the end user. Another prototype, another research project in France. This one is quite interesting because, again, like in the VGG example or other example, we are trying to establish strong partnership with another heritage institution in France, INA. INA is in charge of archiving TV, radio content, and IRIA, which is our main national lab on IT. So Snoop is a visual engine. If you maybe you are using Snoop if you like flowers, trees, because Snoop is the visual engine behind PlantNet app. And in 2018 we tried to apply Snoop to our own collection. The little change here in the pipeline is the impact of human interaction with AI. We have called it, the technical term for it is human in the loop. Here, users are able to select the correct images they would like to obtain at the end. So the green label and the red label are, no, this I don't think this image fit my needs. Please, this kind of similarity AI, please recompute my request. A short focus on our colleagues from the digital humanities side. Visual similarity, for sure, it's very important when you want to explore massive dataset or when one is trying to apply quantitative analysis on such visual dataset. A pioneer at the KB, Melvin Weavers, 2017, again, how can I browse a very large collection of newspaper advertisement using a visual similarity engine. Another project in France, trying again to apply quantitative analysis on visual corpora. This time on Paris Match covers and French daily from the beginning of the 20th century. So big shift, it's kind of artificial frontier, 2020, but then we noted that it was a time of democratization of computer vision techniques and tooling in both the GLAM and the academic sector, and also the rise of multimodal models. Another very interesting project from our colleague at Europeas. In 2020, they were trying to enrich their records thanks to classification model. So again, train models, not applying commercial computer vision model, but they try to train their own models for image classification on very large visual vocabulary, because they are aggregating everything in Europe, from art history content to any kind of to modern pictures. At some point, it was. I said it's very difficult to address with these kind of needs with trained models, because you have to annotate a lot of images and to scale this annotation work for all kind of images. We also around 2020 we also it was also clear that computer vision and AI was a kind of tool for museum, for galleries to expose, to build exhibition. This particular project is a virtual exhibition from the Getty. So again, a massive pictures collection processed by image classification and OCR. Because sometimes picture can contain textual content. This another project, again, from a library, but the intention here was to build an interactive exhibition device, so for the audience, and to my knowledge, for the first time in a library exhibition, they were using AI to the needs of their end users. So the end users, the visitors, were able to use Pixplot, a previous project I just mentioned, and Snoop output when accessing to this collection. As an example, they try to link the picture from Élie Kagan. Élie Kagan was a French photographer from the 1780s. So they try to link pictures from Élie Kagan to reproduction of its work in the newspapers. We should also think that visual similarities can be very useful for our internal work, like cataloging. In this particular use case, at the BNF, our colleagues are trying to answer this question. We have a copy of a poster. Did we already digitize this poster? Do we have already a record regarding this particular copy? So it's very easy now to say, yes, we already have 4 copies of this particular item in Gallica. Again, as previously said, digital humanities are very keen to use this tool. Again, 2 projects, very recent project in France and in Switzerland about applying at scale, meaning millions of images with AI computer vision processing. Finally, is it enough? So I would say no. User would like both. They would like to discuss, to query images or launch the set of images, and they would also like to use similarity. So CLIP 2021. CLIP is addressing these needs. You can ask this kind of model to answer with images or with textual query. Again, one prototype from 2022 on top of museum collection. The Met collection and the Rijksmuseum collection. So you can ask, I'm putting here 2 examples. You can ask this kind of query to CLIP. Maken from Norway. Again, very similar, but Maken is quite unique because our colleagues in Norway decided to aggregate, to mix monographs, covers, also records regarding their monograph collection and images in the same prototype. And WISE, again, from our VGG colleague. The last one I'm putting a the URL. You can test it, try it. It's very efficient. You can ask textual query, and you can mix first a textual query and then an image query, or both at the same time. So you can dig into your intention, into your query with refinement like this. And it works at scale. The public demonstrator aggregated 1 million images, but also try it on Wikimedia content, so 50 million. Last section, yes. Again, it's very artificial, 2024, maybe 2023, but the English for this is conversational archives, archives conversationnelles. Can we interact with images, with text, with voice, with images as a query? So I would say, and Neil later will introduce us to what have been said during the last conference in Canberra, IFLM conference. The big picture is right here. Many tools. All these tools are outputting signatures, and these signatures can be queried, asked, thanks to a vector database or this kind of device, and then end users can query this new kind of database. It's not only about artificial models, it's also about the whole toolbox. I would say many tools are now very useful and very convenient and very available, like database, search engine, compatible with this signature, and so on. An example of such a Lego-based project at the BNF, we are trying to address at scale what I've shown before. So everything in Gallica, 200 millions of scanned pages. We envision at the end to output, we don't know yet, but between 20 to 50 million illustrations. So a lot of processing with many partners who have been funded by the state for this project. At the end, an open database referencing all this illustration on top of IIIF interoperable exchange protocol. And when one has such a database, you can do whatever you want inside for our own needs, but also for our public audience, thanks to open APIs. Just quoting technical architecture of this particular project. As you can see, an AI project is typically a digital project. AI is only the green box, but everything, we need much more, and much more is very classic. It's a database, it's networks, it's about computing architecture. But new thing is here, the green box, segmentation, orientation detection. Sometimes we have scanned illustration in the wrong way, so we now need to orient this illustration and so on. And to end up with a sister project, which has been presented in Canberra. Very similar techniques for the same objective at the end to let people interact with our images and at scale. Maybe a short focus on to finish with we need techniques, but we also need to ask our user how to what kind of application or kind of service they would like to have on top of these techniques. So I'm putting here two references. 2021 work from our UK colleagues. What kind of tool, what kind of design we need. And again, a very interesting presentation in Canberra about the way scholars, researchers would like to have access to this new generation of portal services and access. I think that's it. Thank you.
Yeah. All right. Okay. Hello, my name is Lasse. I'm an IT developer from the Danish Royal Library. I've been there for about a year now, working on a big archive project, which is what I'm gonna speak a bit about today, and how we plan to use speech-to-text to solve some of the issues we see. But first, here is a very short outline of what I'm going to present. A disclaimer, we are still on a very conceptual stage in this project with speech-to-text and AI in general. So we don't have that much to share yet. Hopefully we'll get a lot more experience in the future. But that also means that perhaps this presentation is going to be a bit more granular and project-focused rather than perhaps a roadmap and a strategy. But a small introduction to the project and the solutions we've been discussing, and then questions we'll take at the end of all the presentation. All right. So just a bit of background information. This project that I'm going to talk about is part of a bigger project, and our common goal is to provide access to all Danish cultural heritage material regarding radio and television. So in other words, and a bit more formal, our goal is to consolidate and process approximately 2.7 million older radio TV broadcasts to make the content accessible to citizens by the end of 2026. And just to put it a bit into perspective, the sizes, the volume, so it's about 9 petabytes, 9,000 a terabyte, and almost a million gigabytes, so it's huge volumes. Let's see. And by doing that, we should also meet these media requirements for searchability, compliance, and this highest possible searchability. Highest possible quality. It's a very ambitious project that also comes with a lot of challenges, and the challenges do extend beyond what I'm going to present here. And right now we're working on solving some of the more mundane challenges, but I think it's going to be very easy to see how speech-to-text could help some of these issues that I'm going to present. Most likely in combination with some other technologies. These problems are that our collections have very poor or sometimes incomplete metadata, and that can be divided into two categories. Either it's this critical metadata we need, such as time codes, and it can be more nice to have features such as descriptive metadata, such as genre tags, content summaries, contextual understandings, and so on. And this, of course, does pose a challenge for this goal we have of providing very high quality searchability, but it also makes it very difficult for us to maintain a high level of compliance regarding rights holders and ethical requirements. The archive include both content that is claused, also copyrighted material, material that might need to be censored by today's standards. That can be child nudity from the 70s. So all of these things must be respected in some form. All right. So a very concrete problem we're dealing with right now is segmenting the programs into, of our radio and television programs into programs. So basically, when does a program start and end? Which we of course need in order to first of all find the content we are interested in, but also extract things that we perhaps are not allowed to show due to these reasons I mentioned. And for a large number of files, we actually do have metadata that tells us which radio program to expect at a certain time in a given recording, and we also have the length. So those are the things we need for a segment. However, due to the nature of how these metadata were created, it is very unlikely that they actually provide an accurate representation of the segment we're interested in. Back in time, news publishers media houses usually provided users with a weekly schedule of content, radio content and TV content that you could expect to see at a given time. And later that content have been OCR treated and actually still today function as the main metadata source for very old collections, so dating back to 1920s. And perhaps you already see the problem that when doing it this way, generating the metadata before airing a broadcast, we don't have an updated version. Let's say if a program was cancelled or if it was delayed. So we need a way of validating how accurate these metadata actually are. And for some cases, this is a bit easier. For example, a news broadcast in Denmark often begins with familiar phrases, something along the line of welcome to the news, I'm your host, or it's 11 o'clock, welcome to the news, something like that. So our idea is that by roughly knowing where the segment starts, we have done this is what I'm trying to show here, this fuzzy search, to see if we can kind of narrow in on the actual start time. And this is what I've tried to show here. So, in this case, it's the radioavis that we have been trying to search for from a expected time at 9 o'clock. And as you can see, we our best match, we get a score of 94 from this text bit that says "Velkommen til radioavisen," so welcome to the radio news. So this is a method that we most likely, if we implement it, will use in conjunction with other technologies. But it is a way to try to solve this segmenting problem. Yes. Okay. Another use case is topic extraction with what's called term frequency inverse document frequency, or TF-IDF is an easier way of referring to it. And basically it's extraction of terms and words which occurs in a specific document with a certain frequency that is not common in other documents. And in this case, what we're showing here is this algorithm extracting the 10 most important keywords from transcriptions of 2 programs. And actually the keywords kind of matches the trailer images, which is always nice to see. In the first case, we see a stone smashing a front screen of a car, and in the background we see two signs, the signs as license plate reading Malmö and Ystad. So I think this is a quite good representation. Also, the other example, it's a youth football team together with a trainer, with the text "I want to be a football star," and in this case, the youth football team division are represented by the Danish word U16. But of course, in this case, we are missing, of course, the most obvious word, which is football. But there is still a very good match between what we see in the images, the content, and the text we provide. Third use case is perhaps kind of obvious, but is using speech-to-text to produce subtitles like transcriptions with precise timestamps for, could be for hearing impaired people. And just here I've shown, we've put subtitles from a speech-to-text transcription, from a digitized video from 1996, and in this case we included the timestamps for quality control purposes. And let's see, I have this here. All right. Yeah, and this is just this enrichment process that I've tried to show. So to the right, the table farthest up, we have this repository of metadata that have some columns like descriptions and genres that are missing. And to the left, with the two other repositories, we have these raw visual and auditory files from radio and television. So it's very simple, but if we are eventually allowed to do a large-scale transcription on this archive, like shown here, these other figures just try to illustrate some of the technologies that are available from the transcriptions, like the TF-IDF that I mentioned, the fuzzy string search, also named entity recognition, which I didn't mention, but is another technology you could experiment with. And there are lots of other things you can probably do to enrich the repository, embeddings, all sorts of stuff. And of course it's trying to illustrate that we want to use this to update our metadata repository and get this updated version that has descriptions and genres and a lot of other features in the end. So these are some of our thoughts on how to use transcriptions from speech to text for enriching and segmenting our very old collections. And if we, as I mentioned, are eventually allowed to do transcriptions, this final plot here shows some things we probably also need to be aware of, such as the energy consumption of processing such large-scale volumes of data, since the Royal Danish Library commits to a climate strategy that is trying to create a more climate-friendly library. So this would most likely also be a factor when choosing this as a possible option. And right next to it, we have this estimated time required to process our data. And I'm fairly sure that this is illustrating what it looks like for 1 million hours of mixed radio data. So we tested various platforms, and the blue bars tries to indicate the number of months required for completion, while the line charts is the processing speed. And as you might see, for some of our in-house machines, we average around, I think, 26 times real time, which translates to anywhere from 3 to 6 years for completion. But you have probably also noticed the big outlier on the right. which is how long it would take if we used a model called WhisperJax, which is an optimized speech-to-text model on something called a TPU v4-8, which is a very fancy name for an accelerator or a special type of hardware that does very well with inference and training, and speeds up computations a lot. Using this setup, we can process our data in around 8 months, with 163.5 times real time. So a lot different. But a lot of other factors besides these two will most likely be factored in when we need to do this on a large scale. Most of them, unfortunately, are legal matters. And maybe I can try to summarize a bit here what I mean with if we are eventually allowed. So if I compare to a thing in Denmark called, and I'm pretty sure other countries have this as well, called the Net Archive, which is basically a huge repository of everything we, as the Danish Royal Library, collects or harvest each day as part of the Legal Deposit Act. So it's everything from books, it's web pages, radio, everything daily. So naturally, you can imagine such a repository would be very big, and it is. It's hundreds of billion tokens in volume, so huge amounts of data. But what is very special about the Net Archive is that it is extremely well structured, seen from a metadata perspective. So using it, you are very easily able to find what you're looking for, using different modalities. And it's designed that way, and it's possible because we are a research institution, and the people who can access this repository are only researchers. So that means that as a research, we have this research authorization that allows us to apply a lot more advanced tools to this, because it's for the benefit of researchers that might do social studies, they might do cultural heritage studies, and there are some different rules to play by. If we compare that to what we are doing with this project that I just mentioned, which essentially in the end is going to be a commercial product, we have a completely different rules to play by. Because if we look at it from a speech-to-text perspective, each time you do a transcription on a work of radio or television, that is considered doing a copy of the material or the content, which of course means that the rights holders and the people who own the rights to the content needs to be compensated, probably, and paid. So this whole license module needs to be figured out before we can do this on a large scale, and that's what I mean when I say if we are eventually allowed. But that's a discussion that takes place way outside my pay grade, and on the top of with the legal advisors from the Danish government and from the legal advisors from the rights holders. So they need to kind of sit together and figure out how this mechanism is going to work. And as soon as we get a green light, we can try to push this into a large-scale production. But that's why we have this on a conceptual stage for the most part, and are doing a lot of proof of concepts, trying to present it to our directors and also our steering committees, just to push them a bit, because they have the direct link to the the Ministry of Culture, which we are a part of. So they have a kind of a foot in with the discussions that are going on. But that's it for me. Thank you.
I don't know what happened to my slide, but it got mixed up. Sorry. No, it's not your problem. That should have been my name up there in small. Anyway, hi, my name is Steven Kluijsers. I'm a curator of digital collections at the KB, the National Library of the Netherlands. I'd also like to thank the National Library of Spain and Elena particularly for the very warm welcome here. And what I should add, and thank you for a unique experience you offered me. I'm a great admirer of the filmmaker, Spanish filmmaker Pedro Almodóvar. And yesterday we got stuck in a very, very small elevator over here in the National Library with 6 persons. That was the closest I could get to feeling like I'm in a movie of Almodóvar. So thank you for that experience. I've got 2 small parts. I promise to be short. So first of all, something about the way we're working towards a roadmap for AI at the National Library. And the second part will be about data sheets for digital cultural heritage. At the KB, we've been running quite some experiments for the last few years. Jean-Philippe already mentioned one we did with Melvin Wevers, where we were in 2017, where we tried to look for similar advertisements in newspapers. This is another one. This is again, a small experiment we've been running in the library. This is a collaboration of a colleague of mine, curator, together with people from Technical University in Delft. This is, it's a proof of concept, but it did run. An example of a conversational AI, where we have one particular manuscript depicting various animals, very beautiful, we believe, in the Netherlands. But what you could do here is really ask questions to the manuscript about the manuscript. So tell me, what is this elephant over there, or what is that animal, that red animal in the corner? What is that? And can you tell me a bit more about that, etc., etc., etc. And the interesting thing is, because of this is all by AI in the background, of course. The interesting thing is that we developed this with Dutch information, but you could ask it questions in 200+ languages. And the only thing is, you were not sure if it would answer in that same language. So then you had to urge the bot to really answer in the language you prefer to. So this is what we call the curator bot. It's an example of a really small experiment we've been running. But we've had other projects. Let me see. Yeah, this is a company where we're working together with this company on what we call the retro tool. Retro tool is for the cataloging retro collection. The idea is that we still have books from 19th century, beginning of the 20th century that we come into the library, and then we want to check whether we have this book or not already in our catalog. This is working quite simple. There's a scanner or a photograph you take from the front page, 1 or 2 more pages, and it will scan whether we have this book or this edition already in our collection or not. Of course, that's not for sure. There's no 100% certainty, it's a statistical, but it's a tool for our catalogers, and then the human can check whether it really works or not. Next step will, of course, be use this to start cataloging these books and materials. So we have the very small experiments. We have this is really a collaboration with a company to come to a working, not prototype, but something to implement. And then we have the really big collaborations on a national scale. This is the Cultural AI Lab, which is a collaboration of national heritage institutions like Rijksmuseum, KB, National Library, National Archives, etc., and different researchers from different universities, really looking into the possibilities of AI for culture. And they have this kind of slogan saying it's AI for culture and also culture for AI. So as humanities researchers, as heritage professionals, we should bring some of our critical thinking to AI. That was, and these are still just a few examples of what has been going on at the KB, but there was no strategy below that. There was no roadmap. So when we first saw the roadmap of the BNF, that's a good example, we thought. So now what we're doing is really trying to find out which of these experiments are out there in the KB, because the one from the retro tool is from the cataloging department. The other one is from the R&D department. So in different departments, people are working with AI or building prototypes. So what we're doing now is bringing all of this together, inspired by the example of BNF, and also inspired by a report from the National Council for Government Policy saying that AI is really now, it's just not simply a new technology. No, this is a system technology, meaning that it will affect the whole of society on every level in a systematic way. So which we believe also legitimizes having a roadmap dedicated to AI. So we're now in that process. We made a call within the KB to tell us what you're working on, or are you aware of any project that we are involved in, plotting this over a timeline with only 3 years. It's going fast, so not that long. And then see if we could add milestones, see if we could cluster what is going on, see if we can identify some gaps based on literature, based on, gatherings like this, where we get inspiration of other things that are possible and what is out there, and defining our main focal points. And that's what we've been doing at the moment. We hope to have the roadmap, I think, by the beginning of next year. So I'm sorry I can't present you a roadmap yet. And then there are some unresolved issues. At first I thought it's say heritage collections and copyright, but I think it's broader than that. It's probably heritage collections and responsible use and responsible AI. So these are things that won't be on the roadmap, but that will probably ask for attention for the coming years. Not last summer, but in the summer of 2023, there was a group of researchers. I'll explain what you see here. There was a group of researchers in the Netherlands and data journalists who tried to reverse engineer what Dutch data has been used to train the language model of OpenAI. So in OpenAI, there's also a part that is trained for Dutch, but what data has been used. They don't tell you what data they use to train their models. So these data journalists and researchers try to reverse engineer that and see what data is in there, most probably. And that has been published in the National Journal. And somewhat to our surprise, on 9th position is one of the 2 big websites we have where we publish digitized Dutch. This is specifically dedicated to literature and linguistics. So this DBNL is a Dutch library for literature and linguistics. So what they say is, most probably the whole of that website, all of those texts are used to train that language model used by OpenAI for ChatGPT. Problem is, a huge part of what we publish on that website is material that is still in copyright, sometimes by writers that are still alive. We can only do this based on agreements we have with those people, with the copyright holders, with the publishers, with so-called collective management organizations, etc., etc. So there's a part that is in public domain, no problem at all, everybody can use it, but there's a huge part that's also still in copyright, and where we think we have some kind of responsibility towards the people who have made this and who are still alive, who are depending on this, etc. So what we did is we issued a statement where we said that we are not happy with the way those big commercial, big tech companies are just taking our collections without even asking, without acknowledging that they did, and using it to train large language models. Yeah, there's some controversy with the statement, but that was also in a way what we were trying to do. We wanted to start a discussion. And it's, well, we now have entered a new phase of the discussion because the Dutch government has reserved almost 14 million euros to build an own Dutch language model. And they thought they could come to the National Library and we would give them all of the content we have. But again, for us, they are planning to use this model for commercial purposes, which is even making it, with the new EU laws, quite hard for us. So now we are having this same kind of discussion with our own government. And as I believe I understood from Elena, that is more or less similar to the Spanish situation. Anyway, so these kind of discussions won't be in the roadmap, but I think they will be quite important for the coming years. And then quickly to my second hat. I happen to be the chair of the Europeana Research Community, and in collaboration with the Europeana Tech Community, we've been working on something we call data sheets for digital cultural heritage, and I want to really quickly introduce this. This again has to do with the huge rise of AI and machine learning, meaning that the idea is that we should really learn and work towards having the right documentation and the right information on a collection level for people who are going to use those collections as data, those collections for machine learning purposes, for AI, etc. So it's a way to provide that documentation. Again, responsibility is huge here. So to give transparency, to tell them what kind of biases might be in those collections and what kind of what you can essentially what you can do with it and what you can't do with it. We took the inspiration from this paper by Timnit Gebru. At that time, she was still the head of ethical AI at Google, but got fired. Anyway, she published, together with a few other people, published this paper. Data sheets itself is a concept that was known already in the 1970s. When you had electronic components, there was always this information saying what you could do with that component or what you can't do with it, etc. Gebru and others introduced us to the machine learning community, and what we did with our group is introducing this to the cultural heritage community. So we set up a working group with cultural heritage professionals, experts, humanities scholars, and published a paper, published a template, because that is what it's all about. It's a list, basically a list of questions you'd like to get answered about the data set you have, about the collection you have. So the motivation for the collection, what were the decisions behind it, etc., etc., etc. I won't go into that. Some other examples, so if you have a digitization pipeline, what were the selection criteria, blah, 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 provenance, all things we're all used to in heritage and in libraries, but mostly on an object level. Now we bring this to the collection level. And at the moment, we're working on a transformation to DCAT. So we have a machine-readable form. And we also want to create an online form to guide you through the process of creating such a data sheet. These are the references. These are the people who have been working on this. Thank you.
Maybe it has to be put on the other screen and then click on the presentation. So this has to be put on the other screen and then enter the presentation. Good morning. My name is Tan Lu. I'm the head of the data science lab of the Royal Library of Belgium. And like my colleagues from the other national libraries, I would like to also to express my gratitude for the National Library of Spain for hosting us and for providing such a platform to engage open dialogue. So today I would like to take this chance to shed some lights on some AI activities in the Royal Library of Belgium. But I would take a quick top-down approach where I will first try to highlight some key initiatives on the top level in Belgium before we'll then zoom onto the Royal Library. In Belgium, so the first major initiative in AI was actually launched in 2019, and it is called AI for Belgium. And it was managed by the federal government with the objective of steering, promoting discussions regarding AI development, but also to coordinate the efforts that are being put into AI development between different regions of Belgium. So the government in Belgium is a bit layered, where we have the federal government, and we also have regional governments for different regions where different languages are being spoken. And around the same period of time, in the Flanders region, that's the region where Dutch is being used, the government also launched a very big AI initiative. It's Flanders AI, where we have seen very serious commitment from the government in terms of investing in AI initiatives. For example, providing funds to universities to support PhD or postdoc research, but also try to bring connections between research and industry, and to see how AI can be applied in the context of industrialization. And later in 2022, the first national AI plan was being released in Belgium, and it's also on the federal level, where there are more detailed overarching objectives have been identified and have been elaborated. So we now move on to the Royal Library of Belgium, where I'm representing today. So in KBR, the research and development activities are more or less guided by this action plan, which is renewed, for example, every 2 years. And in the current action plan, which will end by the end of this year, there isn't a clear AI roadmap yet, but it has been noted that we should be aware of what is happening in this direction, and also to explore how we should position ourselves with respect to such developments. But with all the things that are happening with a very fast pace in the field of AI, and with all the inspirations from the other national libraries, I think we're now in a better position to develop a more dedicated AI roadmap in the upcoming action plans in KBR. So in the year of 2021, the KBR Data Science Lab was being created, and it was being created based on the collaboration between the Digit Department of Royal Library and the Department of Mathematics and Data Science of Vrije Universiteit Brussels, where I'm serving as assistant professor. So very quickly, if I reflect on how things were happening and are happening in KBR, I think that the road to AI development actually started much early. And so if I look at the development in KBR, I think around 2011, that's about the same time when the large-scale digitization projects such as Impact and so on and so forth were starting to taking place in Europe. In the KBR, we created the digital department, and this is when we started to have systematic approach to produce quality data with proper control. And it's because of the production of large-scale quality data that has actually enabled subsequent development in the direction of AI. So along this road, once we started to have data, then we started to perform research projects to investigate the data we have produced and to see how we can use the data to improve our service, to optimize our workflows. And those projects then later translated to different research labs, such as the data science lab. And this is in a very big picture how things are being organized or happening in KBR. So what kind of AI activities do we have in KBR? So the first example that I would like to share here is actually the very nice work by my colleague, Hannes. I think many of you may know. He actually worked on the automatic cataloging system in KBR, where the concept is to simplify the process of converting or generating catalog information in the library system. And he used some off-the-shelf tools such as the Microsoft Power Apps, which helped him to quickly convert concepts to actual functioning workflows. And he has already given a talk in the context of the CERN webinar early this year. And if you're interested in his work, there's the link on the website where his presentation can be downloaded. So we move on to the data science lab. I will use 3 slides to highlight 3 different aspects that we're working within the data science lab. And the first one is indeed concerning OCR, and that's actually part of the work where we did in KBR prior to the creation of the data science lab, but this part of work actually contributed to the conceptualization of the lab. So what we discovered back in the days was that a lot of times when OCR is not performing well, it's because this part of the OCR that concerns the classification of text and non-text region is failing. So for the more conventional type of OCR pipeline, what we have is you have 2 separable processes where in the first part you try to identify, given the document, which part of the document contains text and which part of the documents do not contain text. And then for the part that you think there are text, then you feed this part to a transcriber. So this transcription engine will then work on this part and to get the text information out of this region. And the second part is very much leveraging on neural network-based, for example, deep learning frameworks. But actually, a lot of the times, the failure comes from the first part. So if you think about it, for the second part, it has no information about what it's receiving. So even if you provide the transcription engine with the image of bird, it will still try to get a word or letter out of your vocabulary. So that's where the errors are being introduced and make the OCR noisy. So we wanted to address this part by trying to get a better text and non-text like classification. And we took inspiration of human perceptual recognition of the content of a document. And naively, we thought that this was a very easy task for human perceptual processing of visual information. So if you look at a document page, it's fairly simple to you to recognize where the texts are and which part are not text. And we attribute this to the concept of Gestalt grouping, which means that human visual systems are more sensitive to structures that represent or demonstrate certain regularity. And if you see this type of regularity, it actually poses strong stimuli to your visual system. And that's actually helping you to distinguish text regions from the non-text regions. And then we wanted to use a simple graph model and to perform some computational modeling on this graph to simulate this process so that we can review on which part of the image we're seeing this Gestalt pattern. And that gives us a likelihood of how confident we are in believing that this part actually contains text. That's what we're seeing on the screen here. So we compute this, what we call probabilistic local text homogeneity lab. Then we generate a heat map, and which is a probabilistic interpretation of text and non-text, and that's shown there. And from the images, you can see that the more reddish the color is, the more stronger we believe that we see this type of Gestalt pattern in this region, or we believe that this is a text region, and vice versa. And based on this, we developed a layout comprehension algorithm that help us to basically recognize what is what from a page, which is a type of OCR. And this part of the work was actually more or less concluded in 2019. That's right before the release of any large-scale data set that can be used to train a neural network. And that helped us to win a computation on a relatively small set of test images, about 70 pages of magazine extracted from magazines. And since then, we have been continuously optimizing the algorithm, adapting the algorithm on different types of images, and to see how the best we can make use of this type of algorithm. So this is a first example. And the second example concerns our non-text oriented collections. So calcography prints, for example. Our idea in the KBR is we want to see how it is possible for us to make our collections more semantically accessible to the public. So right now, everything is more or less organized categorically. So if you want to browse newspaper, you go to the newspaper section. If you want to look for periodics, you go to the periodic section. If you want to look for calcography prints, then you go to the respective part. But we want to create a link between those type of collections based on their content. For example, if as a user, I want to browse the collection of KBR and I want to search that, I want to say something about people working in the farming field, and then we would be able to say, we have a calcography print actually depicts such a picture, and this is the objective. And so as many of you know, this basically links to contrastive image and language learning, or CLIPS, as my colleagues mentioned earlier. And so we were indeed using one of the recently released variation of the click model to train on our calcography prints. But a very first step is you need natural language description about the content of your prints before you can start the training process. But we don't have this text description about our collection. So what we did there was we used a large language model, and we convert the catalog information that we have about our collection. That's what is also shown up here, but it's very difficult to read. It's Mark 21 that encodes some very basic information about this print. And then we use a large language model basically to generate text description about the content of this print based on the catalog data. And with that, we start to train. And there are a lot of challenges to be solved as well, because as you can imagine, for such contrastive language and image or image language training, you need a large enough sample space where you would see some clustering in terms of semantics. So for example, you have a lot of images that are under the category of cars or birds and so on and so forth. So that will help your model to learn some intrinsic property or visual patterns about those different objects. And at this moment, we have curated for this research purpose about 4K of calcography prints. So now the challenge for us is to see if we could also see a natural clustering in terms of the semantics and the content of this print, so that we can use this clustering to facilitate the training, or we have to bypass this part and find a different approach without having to have such a predefined classes. And that's the work that we're still pursuing in the lab. And the last part is also a very interesting part, which we're currently working on, and it's actually motivated by the desire of optimizing our workflows. And specifically, In KBR, we're digitizing a large scale, large amount of newspapers back in history. And at this moment, I think we have put online about over 4 million pages of newspapers. And in part of this process, in order to organize your digital outputs online for easy browsing, you have to organize your raw digital outputs by editions of those newspapers. And this requires the knowing of which page is a front page of newspaper. And if you know this information, it happens naturally that you can organize your outputs. So it concerns a very basic task of recognizing front pages from different newspapers. And so we started to try to use some AI techniques as well. And we first did a trial testing with a variation of the residual network, which is a neural network structure, on a corpus of about 10K samples, where 2K of them are actually front pages from 8 different newspapers over the course of a year. And there we saw that I think 6 out of the 8 titles, the model didn't make any mistake. And it made some mistakes, like amount to 5 or 6 mistakes on the other titles. But once we investigated into the errors, and it actually occurred to us those were human errors. So those were errors that were made when we were labeling the front page. And the network actually made the correct prediction. So this motivated us to take a step towards full-scale testing of the concept, and this is what we did with the residual net. And we trained the model over 130,000 of samples, among which about 30,000 are front pages, and across more than 100 different newspaper titles. And we saw more or less the same performance, but of course we still have some errors that were produced there. And so I think for about 65 of the titles, again, it was error-free. But for some titles, we can produce as many errors as, for example, 30 or 40. And this actually provoked us to think deeper into this process to say, can we understand a little bit into the operation of the neural network and to understand why certain pages are difficult to classify? Or if we can have something running auxiliary to the neural network that will help us to have a little bit more information about what the neural network is doing in the process of recognizing the front pages. So we use some of the most recent XAI, so explainable AI techniques, and we combine those with data analysis techniques. So at one part of the analysis, what we did was we try to extract abstract prototypes that are learned by the neural network in this process. And from those prototypes, we can identify visual concepts. And those visual concepts can actually help us to understand why a neural network is thinking this particular page is a front page or not. And this is what we're seeing on the screen. So basically, we attribute the decision of the neural network to the original image. And what we're seeing here of the unshadowed region is the region that the neural network is looking at or is using in its decision-making on this page is the front page. And we see that in general, the neural network is looking at the title region of all the different types of neural networks, which is understandable. But we also see that this, of course, what is learned by the neural network is not 100% accurate. As you can see for many of those samples, the attention of the neural network is being directed to images. So if you have a front page and you have a lot of photos on that front page, the neural network will also associate those photos as part of the feature as, this is what a front page should look like, which is actually not correct. And this is the part that we are considering to further optimize regarding different training techniques that we can use in the process. But in the long term, what we want to have is we want to have this technique running next to the neural network. So it will, in the process of recognizing the front pages, it will tell us how it is recognizing the front pages as as a supplementary decision-making strategy that we can employ in the process. And with this, I finish my talk here.
Hello? Yeah. Yes. Okay, so we finished this section of the program. Now, please take the opportunity to share any question, any doubt you have. Yes, thank you. Anna.
Hi. Thank you very much for the presentation. Hi. My question is for you, if it is possible to know, are you using this for transcription? After all this analysis that you are doing, and often I was watching the web pages in my telephone, after that you obtain a transcription of the pages, of the parts? Yeah.
Talking about newspapers?
Yeah.
If you get a transcription, right?
Yeah.
After you analyze the pages of the newspapers.
Yeah, okay. So if I understand correctly, the question is about if the newspaper pages are being also transcribed in the process, and the answer is yes. So in the digitization process of KBR, all the digitized newspaper pages are being OCR. So the objective is to make it fully text searchable. Yes, so they are being transcribed.
Thank you for the question. Any other doubt or anything from the other members of the group? No mercy on our colleagues? No? Yes, Almudena.
Hi, thank you for your presentations. My name is Almudena Caballos. I'm working in a university library. And I just want to ask you, all of you, the relation between the national libraries of your countries with the other libraries, like university libraries, or just with the university, with these technologies or the development of that technologies in your projects. If the universities has any contact with the, I suppose that yes, but how is this relation?
I think Jean-Philippe might want to comment on that.
I would say yes, at least in France, but I think it's quite the same in other countries, yes. We are sharing, thanks to some of the initiatives I just mentioned. As an example, we have a French chapter aside of the main I4LM initiative in France. And this chapter is aggregating university libraries, other kind of heritage institutions. Yeah. And we also have a very strong relationship with the academic sector, meaning because we are hosting researchers, research team, so we are also a very strong relationship on top of our data lab. Data lab I just mentioned is operated by us and by a research infrastructure in France dedicated to digital humanities.
I'll just add, I'm Neil Fitzgerald from British Library. So we work quite closely with universities, so we're an independent research organisation, which means that we're allowed to bid for research funding directly in our own right. And this means that we often work as either principal or co-investigators with academic partners, universities, etc. And we're also part of collaborative doctoral program networks. So we co-supervise and host PhD students. And we prepare areas of interest and we advertise these topics. And then the PhD students and universities then will respond to these things. So yes, it's a very rich connection with universities across the UK. Anyone else?
more or less the same answer, I think, but it really goes from having interns, and we also have a research and residence program where we invite younger researchers to come work with us. The project you mentioned with Melvin Wevers was such a project. He was a young PhD student at that time and wanted to explore this whole new area of computer vision, and we had the newspapers, so that was an example. But we also, on a completely different level, are very much involved in the national infrastructure. It's called Claria. I think Spain also has something called Claria. Yeah, so we are an active partner in Claria. We are active in different work packages, working together very closely with different researchers, different universities. So and the whole range in between. So there are a lot of contacts.
Thank you so much. Any other one? I actually have a question for Tan, and I think I might speak on behalf of my colleagues from cataloging, because we were talking to Hannes on the automated cataloging project. We were looking into how it works and so on. Do you still use that? Do you have plans to continue with that and with that system? Yep.
Yeah, I think what the system that Hannes developed is currently operating in KBR. Yeah. Yeah. Yes.
I would have quite the same question for your layout analysis pipeline. Is it in production or?
Yes, so it's quite a long journey of that pipeline. So yeah, since the competition, we went on to a relatively new journey for us as well. So we went for a patent, which was recently being granted in the States, and we were on the path of exploring commercial solutions of that algorithm. So a quick answer would be yes.
Okay, I'm sure the coffee break will be the perfect space for more questions or more comments and more sharing. So it's ready outside, and well, we started a bit late, but we are doing a good job. Yeah, wow. Maybe we come back at 12. Is that okay? Yeah, 12 as we had initially planned. Perfect. Okay, see you. Nos volvemos a ver a las 12, ¿vale? Hay café fuera preparado. Gracias. Esta agua está para ti. Vale. La puedes usar, ¿vale?
¿Hay clique o hay que darle a...?
Había pedido, pero no hay. Entonces, ¿te importa? Sorry. Tiki, tiki, tiki. Otro check en cosas mal de Elena, cosas que Elena ha hecho mal. Check. Bien. No, pedí y me dijeron vale. Y bueno, por no liar más. ¿Cómo se llama? Es que a mí me encanta ver el... A ver, espera. Okay. Bueno, muchas gracias de nuevo. Thank you for coming back. We are a bit late, but I'm not worried because the beautiful part of this is to share and to meet people there. And we are a small group, so we have been able to talk everyone to everyone and get to know everyone. So I'm very glad to see you back. So now for our next section of the program, we have another 3 presentations from National Library colleagues. And now we have Javier de la Rosa, working in the National Library of Norway. And he will talk about copyright in language models, one of the biggest conversations nowadays. And then Grete Vesalu, right? From the National Library of Estonia, she will share strategies, AI strategies and digital humanities experience and implementation projects. And finally, although it's a classic for us, it's not less important to continue talking about OCR, HTR, how to improve optical recognition, handwritten recognition of characters in our collections. So Neil Fitzgerald from the British Library will share about that. So, Javier, when you want, thank you so much.
Hello, everyone. My name is Javier de la Rosa. I am Spanish, but I work for the National Library of Norway, but I work from Madrid remotely, but I will be speaking in English. Apologies for that. Okay. Should it be, I have to click on the arrow here?
Sorry, we should close the images a bit.
So before I get into the nitty-gritty details of copyright, which is a very fun topic, I would like to give a brief introduction of the National Library of Norway. We were established in 1989, so we are a very, very young national library. We spun off the University of Oslo Library. We actually took over their building, which is a beautiful building in downtown Oslo. And our mandate was to preserve the published information in a region of interest to Norwegian citizens for posterity. We are one of the memory institutions of the country. But also we were tasked with this notion of give our citizens access to the contents, not only preserve, but also to give access to the contents, which became a bit hard to do. In 2005, the then director of the library wrote a manifesto explaining that under her own understanding, things that do not exist on the internet basically don't exist at all. And this manifesto kick-started the whole digitization program at the National Library. And ever since, we've been digitizing our collection. So it's been already 20 years. We've been digitizing literally everything that's been produced in the country. We also have a legal deposit. We get digital copies, PDFs, but also digitize a lot. We established factories of digitization. We bought a lot of equipment. And then for 20 years, we've been digitizing contents. Right now, we have almost 90% of all the books ever published in the region digitized in our archive. Likely 85% of all newspapers are also digitized. For the radio, we have literally everything that's been produced in the country. We also have several petabytes of continuous harvesting of the web content that is relevant to Norway. And we have much more. Like many other libraries, we have many other modalities. We have photo collection, film, magazine, maps, music scores, wax cylinders. We have literally everything. And everything is in digital format. The question is, what are we doing about all of this? Well, the first problem we had is, where are we going to store physically all of these copies, all of these objects? So I'd like to show this picture, which is an installation we call the Mountain Vault. This is literally a mountain in the north of the country that we have basically emptied out. The mountain is now hollow, and we filled it up with robotic shelves. Among these very narrow hallways, there are robots moving constantly up and down, taking boxes and putting books in and out all day, all the days of the year. This is basically one of the results of 20 years of digitization. But the other aspect of it is, how can we give access to all of this content? It's massive. It's impossible to navigate. It's impossible to recommend. It's impossible to even catalog everything that we have in our collection. I know that this is something that much bigger libraries have been facing for quite a while, but the fact that we have entries and records in our collection that were not cataloged was a recent problem for ourselves. So in 2019, we decided to establish Artificial Intelligence Lab with the idea of leveraging AI technologies to make use of these new algorithms to give people access to the content. We have a very large and varied digital collection in the National Library, but we also have our own needs. We need processes, and we have pipelines that need improvement. We need to be more efficient, we need to do more, and we need to do it faster. So the idea of this lab is actually to provide those kind of services to both the library, but also to the citizens of Norway. We are a small team at the moment. We are 5 full-time people. 2 are researchers, and the other 3 are machine learning engineers. That's all the people we have in the AI lab. We're not that many. So we are located mostly in Oslo, where the headquarters of the library are, and then central IT, the 3 engineers are in Mo i Rana, which is a town right above the polar circle. This is not even north for Norway, right? There is even northern parts. There is 1 person from Tromsø, which is even farther up north, and then there is some other guy working from Madrid, excuse me. So what is it that we deliver? Oh, excuse me. The idea is to provide internal and also external knowledge. We create training data sets that are ready for machine learning consumption. We provide APIs, we train our own custom models for our own purposes. But the most important aspect of this is not the things we do that are successful, but all the experiments that fail. The AI Lab is a safe space for experimentation. We are allowed to fail, and we fail much more often than we are successful. And that is okay, because we are allowed to do that. So out of 10 experiments, maybe 1 or 2 are successful. But that's okay, because that's the purpose of this space. And I think that that's the key for the success of a unit like this. But how do we do this? Well, it all started by counting words. You all know that. And the counting word got more and more evolved. And then some researchers discovered that actually, when you count words, you can get lists of numbers that kind of represent the meaning of the words. And then a whole explosion happened. You can actually do mathematical operations with this list of numbers, and you are operating in a semantic space. That was kind of mind-blowing. For example, if you take the representation for the word king, and then you subtract the representation for the word man, and add the representation for the word woman, what you get is something that is very, very close to the representation of the word queen. So you are using math, but you are actually operating in the semantic space of this vocabulary. That was kind of mind-blowing result, but this is old now. This is like from 2013. Things have evolved much more than this. A natural evolution of that was the extension of words to actual longer chunks of text, paragraphs, pages, and even whole documents, which they call the doc-to-vec approach, but it's based on the same techniques. We use this kind of idea and apply it to our own collection. This list of numbers in the jargon are called embeddings. So when embeddings are close to each other, it means that these representations are semantically similar. They share some attributes, they share some sort of notion of relatedness. So we say, okay, let's try to take this a bit further. So let's apply one of these models that basically converts text into numbers to our own collection, and then let's try to look for similar items. So given a book, first we get the numerical representation of that book, and then we compare that representation against the representation of all the other books in our catalog. We rank by how close are these numbers to each other, and then we get which ones are more related to the book that I was looking for. And this is mind-blowing for the fact that it's not using any metadata at all. There is no metadata explaining who the author is, no metadata explaining what the title of the book even is, even though it might be in the cover. But it's only working with the textual content of the books, which is surprising, and it works really, really well. We applied this idea to a production system we call Machen. Machen literally means the matching other in Norwegian, because once you have one element, you can get the matching other of this element. We created some sort of user stories to understand how people were using this service. We talked to historians, researchers, journalists, and they were all very happy with the results, and they all reported like with systems like this, they were able to experience some sort of serendipity. Sometimes the results they got were really, really good because they were very similar, but the other results that were not that similar turned out to be more important to their own research. The problem with these approaches are that, yes, you get a lot of semantics and similarity stuff, but it doesn't work very well with language understanding. It's not understanding how the language actually works. Then enters BERT, which is the name of a family of models that it's supposed to actually understand language. It's not very good at classifying very long chunks of text, but it can classify almost anything related to text, from very short sentences to even parts of a word. I say part of a word because that's what a token is. When you hear in AI people talking about tokens, they are actually referring to small chunks within one single word. Sometimes complete word, most of the times sub-words. And you can think of any kind of classification, from part of a speech, name entity, recognition, sentiment analysis. Everything is covered by these kind of encoder-only models. Problem is, to train something like this for Norwegian, you need first an architecture, a foundation model to start with, but also training data. And there is a heavy tech environment that is needed to train this model. It's very costly to maintain. The cost, fortunately, is going down now, but it's actually kind of costly to maintain. So we use some sort of Google support for this, and then for the training data, because we are the National Library, we use our own library collections, which is something that every national library should do, by the way. So we say, okay, let's try to build the first Norwegian transformer model. The problem with this is that size actually matters. So if you are feeding one of these models with very small amounts of data, you're not going to get a good performing model at all. But quality matters even more. So we put a lot of effort into curating the data because we're very close to our collections. We know exactly the quality of the data. So at the beginning, when you start working on this, you think, okay, first, dataset creation, curation, selection, cleaning processes, and then we pre-process the data. What's the right data? Make sure, should I balance with other languages? And then the training part, batch size, optimizer, learning rate, very hyperparameter oriented. But actually, if we reflect on all of this, the important part at the beginning, the more you train models, you realize that the most important part is actually the data. All of these models are tending to behave almost exactly the same. In our library collection, we have everything digitized. Sometimes it's OCR of bad quality, and then we have to re-OCR everything, and then we have problems with Central IT because they don't want to re-ingest things that are not in Alto XML format. Typical things that happen in national libraries. Other things are in PDF already. We also have HTML. We have all sorts of different sources that we had to clean. And then we mix some of that with other internet sources because Norwegian law allows it. We cannot redistribute these sources, but we can train on them. We have to reject almost 40% of all the data we had because of OCR quality. That's now fixed because we have iterated many times across this. And then we were able to get a data set, mostly in Norwegian, 99% Norwegian, that was rivaling other data sets for English. This is now a ridiculous amount of text. These days, people are training on like trillions of words and trillions of tokens and things like that. But we were very proud of our small effort in getting a Norwegian mostly data set and also model stream. In fact, when we benchmarked this model, we happened to be not only the best Norwegian model, but also the best Danish model, which maybe he didn't know. He's from Denmark. This is a student, a PhD student, Kenneth, who make a comment, say, hey, the Norwegians have created a model that is better at Danish than the Danish models. So we were actually kind of happy. But these models are actually very easy to adjust, easy to fine-tune to other purposes. You can create these models specifically for name entity recognition, sentence embeddings, textual entailment, that is telling whether two sentences are expressing the same idea. So they're very powerful, very dynamic, but you still have to adjust them. But what about generation? These models are not good for generation. They do not generate text as they are. And that is because the way they are trained, right? In these BERT models, there is a pre-training phase and a fine-tuning phase. And they are both different from a code perspective. While in the autoregressive world, the GPT-style models, the way you pre-train the model and the way you adjust the model for other domains is exactly the same. So that's a big success, because now you don't have to have two different infrastructures. You can do exactly the same with the same setup that you have. That's a huge win because it simplifies a lot the things that you have to do when you have the data. That's one of the reasons these models are getting very popular. It became an explosion of models. In the period of like 3-4 years, tons of these models were released because it was kind of easy to train them. It was kind of easy also to adjust to different domains, but it was very difficult to evaluate at the same time. They were generating text, but there were very few ways to say if the model was actually any good at all. We trained our own model. We collaborated with a newspaper editor who were using this model to generate article titles. And our model trained in this way, in an autoregressive way, was actually beating other bigger and better models. So actually our Norwegian model, autoregressive, producing text in a generative way, was actually very good. And things just got crazy after that. There is this thing called JAMA, which is a way to adjust this model to behave like a person responding to questions. When you talk to ChatGPT, what is behind that is first a foundation model trained on just trying to predict the next word, but after that there is a post-training phase in which they adjust the model to be able to follow conversations, to mimic a chat, to reply to questions. And this whole technique called post-training or alpaca-style training came after a model released by Facebook, which is called JAMA, hence the alpaca thing. They are very creative with the names. We also trained an alpaca model, and it turned out that with very few examples, the model was actually able to follow the instructions of the users. It was not yet chat ready, but it was actually following these instructions. We also work with other modalities like speech to text, which is also enabling other kinds of access to the material we have. For example, we can now find people names, location names, organization names in speech by a two-step process. First, we transcribe everything, and then we run one of these models that I just mentioned to actually find the entities. But training these things are actually not it's not like you train a model once and you are done. We did like 90-something different trainings just to get one model that was actually working well. So it's not like you have the resources, you train once and you are done. You have to have a proper setup to do evaluation, to see if the model is any good, to iterate over, and then go back to your data, examine the data again, and iterate, and iterate, and iterate until you get something that is actually working well. I'm very short on time, so I'm just going to skip some technical details about Waft2Vec and Whisper. Why Whisper is super popular, but Waft2Vec is not, is because Whisper actually produces punctuation and capital letters. That's actually the only reason Whisper is super popular, because there are Waft2Vec models that perform almost on par. We train our own MB Whisper, and then we also have other modalities. We have like a front page detection tool, like the one Tom was talking about this morning. We applied clip models like the ones Jean-Philippe mentioned. We also have handwritten text recognition applied. The things about clip models is that they're very fun to play with. You can literally say, kids playing in the snow, and then you'll get pictures of kids playing in the snow. You can even go a bit crazy. Do I have pictures of a horse in a living room? Yes, there is pictures of a horse in a living room in the collection. And all of this led to the Mimir project. To give you some sort of sense in the timeline, ChatGPT was, can I have like 5 more minutes? Yeah. In November 2022, ChatGPT was released. In January 2023, they improved the model and released GPT-4, right? ChatGPT was probably the first publicly released product. It's not a model anymore, it's actually a product. It's not a single model that you make questions and get responses back. There is a whole pipeline surrounding and wrapping these models with mitigation strategies, with arbitration, with a lot of different ways to not produce harmful content, because they can be liable. They're a company, right? So they have all of these safety rules in place. But it was the first time people realized that you can actually talk to an AI and get something of value in return. It can do summarizations pretty well. It can give me an initial draft of an idea that I have. It can actually translate stuff. It can almost answer some questions very vaguely. So people started to get nervous, very, very nervous, especially in the US. Many different right holders, representations sue OpenAI, Google, Anthropic, Amazon, because they were discovering that the training data actually included material under copyright. They were not disclosing it, but they were reverse engineering these models to discover that, in fact, they used their material without their permission. So in November of 2024, a couple of right holder organizations in Norway representing both printed media like newspapers, but also authors and creators, books, basically wrote a letter to the government, to the Ministry of Culture, demanding compensation because we were training models using copyright material. This is the actual translation of the letter. I'm not including here the amount of money they were asking for. I'm not allowed to do that. They were asking for a lot of money. But the government said, okay, it is reasonable. It makes sense that if we train with copyrighted material, that the authors get compensated. It makes total sense. But before we establish an amount, quantity to get paid, let's see how the performance of these models change when the copyrighted materials are included in the training sets. So hence, the MIMIR project was born with the idea of assessing the impact of copyrighted material in the performance of generative large language models for Norwegian. We got a mandate directly from the Ministry of Culture. We are the National Library, so we could not say no to this. And they asked us to do this study in 6 months. This is a massive study. We have to also collaborate with other universities, research universities here, with the Supercomputer Center in Norway, with the Supercomputer Center in Finland, which is called Lumi. And we have 6 months to do everything. From data curation and creation of the data sets, to training of many different models, to the creation of an evaluation suite that was meaningful, to the actual writing of the report that will go to the government. It was hectic, 6 months of chaos, but it was also pretty fun, I have to admit. So the methodology was, let's assemble a diverse corpus representing everything we have. Let's do some model training with different ablations of this data that we have, and then let's create and evaluate all of these models on very specific tasks. We created 2 main data sets. One is MIMIR-based, what we call MIMIR-based, which it would include content that is of free access, for which we also have agreements, so in theory can be used for training large language models. Unfortunately, turned out that there were actually restrictions when we thought there were no restrictions at all. And this is in light of the results we got from this very same study. They demanded to change the way we were interpreting past agreements in the light of generative AI. I don't know if that's fair. That's for the lawyers to decide. And then MIMIR Extended, which included everything under the sun that was written in Norwegian. And some ablations out of this. For example, the base content plus all the books, the base content plus all the newspapers, all the books and all the newspapers, only the nonfiction and the newspapers, kind of a factual kind of training, only the fiction, only the translated literature to see the different effects in performance of these models. We trained like 17 plus models of 7 billion parameters. To give you an idea, these models are 25 times smaller than GPT-3, and they still cost a lot of money to train. We spent like almost 300,000 GPU hours to train all of this, which is a lot of compute and a lot of carbon emissions. although they are usually offset by the supercomputer centers, so they say. And we train all these different models, and then we compose an evaluation suite, grouping 9 higher level skills, like how the models do in sentiment analysis situation, how fair or truthful their outputs are, how their reading comprehension ability is, different skills. And then we collected everything. Making sense of so much data is extremely complicated. So any representation of these results might change slightly if we do the aggregation in a different way, but we did at least 5 different ways of aggregating all the data, and the results were aligning pretty much all the time. So this is just a summation of all the scores instead of an average or any other kind of aggregation. And here you can see clearly, maybe not super clear, but you can see clearly that the best model is the extended one, which actually included all the in-copyrighted material. That's training the model from scratch. When we use a pre-existing model, the difference between the models trained with books and newspapers and the model trained without it decreases to the point of being almost negligible. There is still an effect, but if you're training on top of other models, the difference is decreased. But that's a problem, because these other models, we don't know what they train their models with. So probably this Mistral model was also trained with copyrighted content. This is like a proxy to a response to that question, but we don't have definitive answers for this. And I'll finish with one more slide here, which is the effect of fiction. When you compare the different ablations with regards to the performance of the base model, you see that adding material usually makes the model better, except for fiction books. Fiction book is detrimental to the quality of these models. Now you have to take this with a pinch of salt, because it's easy to decompose these scores, and then you will see that, for example, yes, fiction is bad for sentiment analysis, very bad for fairness and truthfulness, but for example, is very good, no, here's also bad, is very good in readability, is very good in the variation of the language used. These are the only metrics kind of related to creativity that we have for the Norwegian benchmarking suite, and it's not very common to have them. There is no way to measure creativity. It's a very subjective thing. So even though fiction seems detrimental to the performance of all the other, maybe more monetizable metrics, it's still very good for creativity. So to conclude, yes, this is also some other stuff that we did. What are the consequences of this? Well, first, there are new projects spanning out of this, transcription of the Great Archive, more model like this, but we also got acknowledged by the government to such an extent that they are now funding a new unit within the library to be like a pivotal, like a central key player in the development on Norwegian large language models. We are funding a new unit with 20 people. We are 5 now. We're going to be 20 in a year, if we can hire that many people to work in Norway. And now we are part of also of the digital strategy and the budget lines for the 2025 to 2030. So my advice would be, even if you are underfunded and you don't know what you're doing, keep doing it. At some point, you will be able to see the results. Thank you.
Hello, I am Grete Veesalu from National Library of Estonia, and I'm the digital curator for cultural heritage. And now, because I'm a historian, so as a first point, we will take a little detour to Estonian mythology, but I do promise that it makes sense further in my presentation. So in Estonian mythology, we have Krat, It's a magical creature crafted from household objects or farm tools. And it's animated to perform specific tasks for its owner that are usually connected to bringing wealth or goods. And the creation of a krat often involves a pact with a devil, and there is a possibility that the krat can turn on their creator. So obviously we use krat metaphor for AI and more specifically for machine learning in Estonia. So briefly about our national AI strategy. In the last 5 years, we have done a little bit over 130 AI projects. We have this rule that all projects, IT developments, procured by public organizations that are using open source code must be published in our national code repository so that those can be reused. We are also part of LUMI consortium, and for our AI automatic cataloging, we actually use LUMI's computing resources. We now also have a white paper on data and AI, and from that white paper comes the regulation that every public institution in Estonia has to have a specific AI strategy by 2030. As of now, in the library, we have data plan and data management strategy, but we don't have a specific AI strategy. But in 6 years, we have to have one. We also have a brand new AI strategy. It's a third one for us. The first one was published in 2019. And two biggest highlights from the strategy are that by 2026, we have to have 300 AI projects carried out. And as Estonian is a small language, we need, and nobody else will do LLMs for us, so we need to make them ourselves. Then we aim to have also data set of quality, also referenced, up to 15 billion words. Right now we have 4. And which is actually a problem because also our partner for the automatic cataloging endeavor had to create some synthetic data for training the material. I also put a link in there to see the documents, but the strategy and the white paper are right now only in Estonian, those haven't been translated yet. So I will now briefly talk about our AI and data humanities applications that we have at the library. We actually started a few years ago with a prototype to figure out if it's even possible to do automated cataloging on Estonian language material. There is also a link for that, and Marta is still up and running if any of you wants to check it out. The project was successful, and we did continue onwards with an actual working solution. It was a public procurement, Marta, and a really big problem for us was that there are about 5 to 10 companies in Estonia who are actually capable of doing something like that. So now we move on to our krat. She's called Kata. We are in early stages of the development. We want to make a fully automatic process for legal deposit files. National Library of Estonia is a legal deposit library. So it's a modular solution complying of 5 components and 5 microservices. And the idea is to to get to the point that, once the files are deposited, then magic will happen and we have bibliographic description, we have full text files, we have subjects, and also NER and authors with VF codes and linked data and all sorts of that. We are also collaborating with National Library of Finland, and because they are part of University of Helsinki, then also kind of with the University of Helsinki. We try to, or kind of work towards using ANIF, their automatic cataloging system, in our solution. And our next big step would be trying to work on the web archive, which in our case, only this selection of the web archive that is part of the national bibliography is described in the catalog. So the rest is a wild, wild west. And we are really waiting for AI's and machine learning's help in making sense of that. We also want to work with libraries of universities and other research institutions, and possibly also provide the services of our CRAT for them. I will now briefly talk about our DigiLab, which is our CLAM lab. One of the aims is to provide data and cultural data to researchers, students, just people who are interested in that. Another big idea behind that is to clean and organize the cultural data that we have and sort of popularize it a little bit more with, we have blog posts, they are doing presentations, but also academic papers. And the National Library of Estonia, because we are a deposit library and also have the biggest digital repository, we hold the biggest data in Estonian language. So we are also data provider for example, Estonian Language Institute and other universities like the Technical University, who is working on speech to text and sort of that. Here are some examples of the data we have in the DigiLab, and there is a link to the Git. And some case studies and blog posts, and our team is very hard working at getting the blog posts also translated into English. The two latest and biggest initiatives are the created Estonian National Bibliography. There is also a link to the Git for the code, but also like more maybe softer side is collaboration with students for thesis teams. So the current thesis topics that are in works are evaluating and improving OCR quality for both the modern and Gothic script. Fraktur is a very difficult thing for OCR and automatic cataloging and all sorts of that. Analyzing personal ads and postcards, and also sentiment analysis of newspapers. And now I will talk about Digar. Digar is my baby. Digar is Estonian kallika. We are implementing IIIF with our digital collections. We are going to IIIFI our entire collection. It's up to 10,000 images, including screenshots made during web harvests. We also, because Estonia is small and the data amounts and money that it costs are big, we are also going to start provide service and provide infrastructure and IIIF compatibility to other CLAM institutions in Estonia. And with IIIF, our biggest challenge is to figure out how to reverse engineer IIIF's interoperability, because we have a lot of in-copyright material that can't be made public to the entire world. So we have like right now 4 different microservices that are working on closing the access to some of the material. We also already employ AI and machine learning in DIGAR. From the same automatic cataloging CRAT, we will get metadata enriched full text files in JSON LD format. The CRAT will also improve the OCR quality and the descriptions, so it will work for us for that too. We are using linked data for authors, organizations, and locations. We want to improve accessibility and findability with that. In accordance to EU directive, we are also going to start to provide text and data mining to scholars. This is very closely tied to our renovated building, where we will have some hardcore hardware that helps with that. And we are also using Neurogana, which is a speech synthesis software that is developed mainly by University of Tartu, and it uses NLP to produce more human-liking sounds. The demo and code are also public and up in the internet. We already have funding for the next phase of development that is centered on data and citizen science. We want to create more opportunities for users to engage and actively engage with our collections, not just flip the pages of magazines. We will build a little bit more hardcore user interface for those digital humanities and data scientists who don't want to work with the code or command line. And in collaboration with our DigiLab, we will also work more closely on API access to the content that we hold in DIGAR. We also want to expand the usage of IIIF protocol, including the APIs, but also more of machine learning options that we have with that. And now it crashed a little, so we need to wait. Oh, it's here. So now this is not the National Libraries thingy, but this is our Ministry of Economics, and you can already see maybe a little bit of a wordplay there. We have CRAT, which is already familiar to us, and Bureau comes from bureaucracy. So we have this bureaucracy AI. It's basically an AI virtual assistant that all public institutions can use with their services. I also had a little 2-minute video here for that, but it's not working right. It's okay. No, it's no problem. The idea behind the bureaucrat is that you have this chat or text robot that you can, to the point that you can order new ID or notify police that my documents have been stolen, or also the vision is that you can lend a book via bureaucrat. And also we were awarded in 2022 at the World Government Summit in Dubai. And that's all. Thank you.
Here you are. Yes.
Great. Hi everyone, I'm Neil Fitzgerald, Head of Digital Research at the British Library. So the Digital Research Team was established in 2012 following a review of the library operations and with the idea to support digital scholarship better, both for the organisation and for our users. And last year we also established a dedicated Universal Viewer team, and Universal Viewer is the main viewer, IIIF powered viewer that we use to provide access to our collections. And this is important not only for improving general access to our collections, but also to take into account the increasing volume of annotations and other crowdsourced and machine-generated annotations becoming available. And just looking at some AI activity at the library, we say this covers everything from machine learning, data science. Staff have been experimenting with these approaches for many years. And we provide various ways to support staff from within our team. And that includes a training program, which I'll mention shortly. And we're currently writing a Principles for AI at the British Library document and an ethical statement. And as Jean-Philippe mentioned earlier, there would be interest in maybe sharing this effort with other CENL members. And the importance of AI, you know, this is something that will affect everyone. So even if you don't participate in projects directly in your institution, you will be affected by AI, which will be packaged in products that you use at home and with your family. So it's really important that everyone has some awareness of the implications of using products that you buy or consume. And our biggest AI project to date at the British Library was Living with Machines. So this was an AHRC-funded project, and we did this in conjunction with the Alan Turing Institute, which is the National Data Science and Artificial Intelligence organisation in the UK. And there's, via that link at the bottom of the slide, you'll be able to find all the outputs from the project. And as I mentioned, since the team started, we've run an internal training program, and this is about building digital scholarship capacity and capability across the organisation. And this also supports staff who participate in interdisciplinary projects with academic researchers and other parties. And we cover all types of topics. Jean-Philippe mentioned the training resources which are available via AI for LAM, and we're currently working as part of a LIBA working group to develop a digital scholarship essentials topic guides, which will be available for anyone to use. So there'll be an open source product, and anyone can contribute to those. And yeah, so this is the training program, and we have a mixture of channels, so everything from a digital scholarship reading group, a hands-on hack and yak, so this is a monthly informal session where we get together and maybe work through tutorial, try out new services, new tools, and anything that proves valuable from both of those may be developed into a more formal training program. And OCR has been mentioned many times here, and the BL's interest in OCR work really started in the early 2000s when we began large-scale digitization of newspapers, and some academic researchers asked us for the OCR to do text and data mining, and realised how bad it was, particularly for historical content. And this directly led to the Impact project, the EU-funded project looking at improving OCR, particularly for historical collections, which you're familiar with. And I guess in some respects the world has moved on, but OCR is not a solved problem. As I regularly share on social media, probably 2 or 3 times a year, people think everything is solved. And one of the more recent developments in this space has really been Transcribers, which came out of 2 EU-funded research projects. And the classic case of what happens to research outputs when project funding closes. So the READ Co-op was formed, and this is the group that manages Transcribers. So it was set up as a European social cooperative. And thinking about the discussion, the very heated discussion sometimes that's going on at the moment between Europe and North American tech companies, how do we have skin in the game here? How do we I wouldn't say compete in this space, but how do we have a voice in work that's going on in this space? And I think it's really important that we are active participants here. And the READ Co-op social cooperative is a really good example of a potential model. So the project outputs are being sustained through the social cooperative. The British Library is one of the shareholders in Transcribers, and all profits from running Transcribers are reinvested in sustaining and extending services. So this is, I would argue, a very good model for making sure the tools which are available to collection holding institutions stay up to date and provide the features and functionality that users want. The other appeal for using a platform like Transcribers is we're a relatively small team within a large organisation, and it would be impossible for us to personally support everyone who's interested in doing OCR and handwritten text recognition projects. And due to the colonial nature of our collections, we have collections in most known languages and scripts, and it really needs subject matter experts to work on these projects. So by using a platform like Transcribers, these subject matter experts are able to work with a standardized tool set, and that makes it much easier for us to support this work within the organization. And just looking at some of the examples of these non-English collections at the BL, we recently completed a project called 2 Centuries of Indian Prints. So we have 22 South Asian languages in our collections, and we wanted to improve access and understanding of this collection. And the first theme that we tackled using OCR and handwritten text recognition for Transcribers, after doing some assessment of available tools, was for Bengali books. And we developed a pipeline using a combination of Transcribers and Power BI to manage the workflow. And this allowed us to transcribe over 1,200 books, 1,200 Bengali books as part of the project. And I think one of the things that we need to keep in mind when we're doing this type of work is the engagement with the wider community. So we've heard a lot about infrastructure and technical development of workflows, And I think there's been some really exciting comments, thinking about using IIIF to power not only display and delivery of digital collections, but also enrichment and supporting machine learning uses. We have been using IIIF-powered crowdsourcing platforms for some time. And one of the things we're hoping to do is have a sort of a virtuous circle of using a mixture of human-generated and machine-generated transcriptions to then feed in and train models. And this was a really nice example of Javanese material in our collections. We partnered with the Wikisource community, and they transcribed a large volume of data that fed in as training data in creating a model on transcribers. And for that community, they really appreciated the opportunity to participate and also to recognize that they were having a long-lasting impact. So that model is now available for processing other similar content types. And another example here is Arabic manuscripts. We have over 15,000 Arabic manuscripts in our collections. And another approach that we've used really successfully to develop better solutions in this space is running competitions. So we've run 2 competitions associated with ICTA, which is the premium or the headline conference of pattern recognition and OCR and document understanding. And we created data sets and ground truth data, and we made this available to researchers. And these competitions we ran in conjunction with Prima Research Lab at University of Salford. And just looking in a bit more detail at some of the challenges in the competition, so we, as you're probably familiar, there's different stages within the post-capture processing workflow. Each are really important. And segmentation layout recognition is an area that still needs further improvement, and the success of those stages really affects how well text recognition is carried out. So the competition was in each of these areas. This data is available on our research repository. And even though the competitions have finished, it continues to be downloaded and used by researchers. So there's an ongoing positive impact of spending the time and the effort in creating the data sets and the ground truth in the first place. And I would argue for collection holding institutions which potentially don't have high levels of technical capacity, this is a really successful route to improving access to collections in general. And a similar project, so crowdsourcing Urdu transcriptions, and again we needed sufficient ground truth to feed into the development of an Urdu model. This work continues. But it is an approach that we will use for other projects. And a big area of interest is on Chinese. So this, we have a large Chinese collection at the British Library. We have some high-profile international collaboration projects like the International Donghong project with partners from BNF and other partners are involved. And currently, eScriptorium, which is another open source platform, is probably strongest in Chinese recognition. And so we had one of our PhD hosted students who is a Chinese specialist who worked with us for 3 months on improving Chinese handwritten text recognition. And these were the 3 areas that we worked on, so binarization, segmentation, and transcription. So you can see within the images some of the issues. So you'll probably be familiar with a lot of these problems. So how visible text is or faded text, colors, overwriting, show through, all of those classic issues for OCR and HDR recognition. So Peter methodically worked through each of these areas and worked very closely with the developers and has made a substantial contribution to improving recognition of Chinese HDR. And probably thinking about, well, how can these approaches solve some of the real issues within libraries? And it was funny, as we had a tour around here yesterday, we saw some of your cards catalogues. And we at the BL still have hundreds of thousands of card indexes which haven't been converted. So the content, not all content is available through our electronic catalogue. And this particularly affects non-English material. So we have been looking at a way to efficiently convert these card indexes into electronic catalogue entries. And this project has been running for some time, predominantly with Asia and Africa material. And we've taken the card indexes, we've applied OCR and handwritten text recognition. And as you'll see from the card indexes, you have a mixture of challenges, so typewritten, handwritten annotations, and yeah, overwriting, all of these problems. So we've tried a few different approaches, and we have found now that a combination of the latest machine learning models which we've generated in Transcribus, as well as some more traditional computational approaches have allowed us to generate valid entries that we can put into our own catalogue. So we do recognition of the card indexes. These are matched via an API to OCLC to see if there's any matching records already available. And if there's more than one choice, we then present the choices to subject matter experts, so cataloguers in this area, and they choose the best match. So from a scaling perspective, this allows for a large volume of cards to be processed. And this has, just in the process of moving from the proof of concept into production. So Harry, our research software engineer, built this Streamlit app, and this is what manages the presentation of the card results to the curators. And then just looking at future plans, we very much want to make OCR and handwritten text recognition, so moving from a project-based approach to making it business as usual for all digitization. So particularly any new projects that start, and for legacy digitization, it's building those workflows that will enable us to process that data and improve discoverability for our users. And I think for lots of collection holding institutions, this will be a step change, moving away from linear workflows to maybe a more iterative approach. and applying different types of processing to different content types and formats. And to support this, we've just recently recruited a dedicated digital curator whose focus will be on OCR and HDR, and then later on speech to text. And I'll just quickly touch on AI for LAM. So AI for LAM is artificial intelligence for libraries, archives and museums. It's a network which has been in operation since 2018. It has an annual conference every year called Fantastic Futures. And the first conference was at the National Library of Norway in Oslo. Then it went to Stanford. It's also been at the BNF. And we had a slight interruption for COVID, so we had to have some virtual events. It was at the Internet Archive in Vancouver the year before last, and this year I've just come back from the National Film and Sound Archive in Canberra, and there was a very successful conference, mostly in person, but also live streamed, and recordings will be made available. And you can access all the details of all these past conferences on the AI for LAM website, so aiforlam.org. And there's also monthly community calls, and there's special interest working groups. So, for example, there's one on metadata. So if you're interested in finding out more about different topics, you can review past community calls and look at the recordings. And we also have this AI for LAM awesome list. So this is hosted on GitHub, but there's also a simple form. If you have any resources that you want to contribute, you can just fill out the form. And it's a very good resource for teaching and learning materials as well as software and data. So have a look at it, and everyone is more than welcome to join the community calls, and you can find out the joining details on the website. There's also a very active Slack channel, and again there's different channels for different topics and themes. And I'll just finish to advertise and invite you all to Fantastic Futures 25, which will be hosted at the British Library in London, the 3rd to the 5th of December. And the call for papers will be going out in the new year. We will share more information about what's expected, but a combination of workshops, papers, lightning talks, all the usual things that you get at the conference. And that's me. Thank you very much.
Hello. Yes, thank you, Javier, Greta, Neil. We would like to have questions. Any questions, any doubts from you about these 3 inspiring presentations? No? Yes, thank you, Anna.
Sorry. It's just following the Greta, maybe? Yeah, following your presentation, it wanted to know if you are using AI technologies for engage the users with disabilities, or some of the others. If you are with
disabilities,
yeah.
Mm-hmm. So,
yeah, this is the question. Sorry. To whom? To Greta or whatever.
So you're asking about ways of including people with disabilities in all these...
in the libraries, if they are thinking in using the AI for that.
Yeah. Any thoughts? Any? Grete or anyone? Ways of including people with disabilities in all these new projects, initiatives, and so on.
Okay. Basically, the neurogonna solutions that we use for mostly for people with disabilities, because under Estonian legislation, people with disabilities have access to the entire collection. Like they are from home or wherever they are, and they can also download and use those material in their applications or hardware that they are used to. And so basically why we also went with Neurogene, there is also one more older version that most of the institutions still use, is that it's of better quality, and we maybe aim to reach a point where we don't need to create separate DAISY formats or whatever kind of formats for those people, but they can listen to with you know, really good quality the material from the web.
Thank you. Yes? Okay. Any other thoughts? No? Okay. We would love to have more questions, but if it's okay, yeah? Yeah. Inspiring, right? Yeah. Okay, so Tan and Steven had to leave for the airport already, but let me ask you for a last round of applause for our CNL colleagues who gave, please. Thank you so much. It was great. Thank you. Okay, so now for the next presentation, Salvador, please. We thought it was a good idea to have a perspective on AI from the research field. We think it's essential to follow, to have this view on how research methodologies have been transformed within digital ecosystems and how this transformation affects the needs, the opportunities for collaboration, the relationship with national libraries and the big information and knowledge centers, right? So to explore this, we have here Claria, which is a strategic national research network. The National Library of Spain is a member. And actually this afternoon, please remember, we have a session, full session from 4, right, to 7:30. A session co-hosted with them here, where we will look into specific research cases, and of course you are all more than welcome and invited to stay. For now, Salvador Ros will give an overall view of the network and their perspectives with regards to AI. Thank you for being here.
Thank you for inviting me. It's a pleasure. And then to for aquí.
Sí.
Tenías ahí.
Oh. We are seeing all your secrets now.
I have no secrets. Just only presentations. Okay. Okay. Thank you very much. Thank you to the National Library for this invitation. I'll try to explain very briefly, because I know that you are tired, what is Claria is. Okay, the title is CLEAR. It's a strategic network for integration in the European research infrastructures in social science and humanities. So this is what we are going to talk about. In the origin was maybe 8 years ago probably, was the environment here in Spain was that just a few people was talking about digital humanities or infrastructures, but except UNED, that is my university, so it's logical. Two more universities, one in the País Vasco and the other one in Barcelona. All together, with the improvement of a ERC project that is called Postdata and the participation of the Laboratory of Innovation in Digital Humanities, we built an ecosystem that's starting to be worried about the role of Spain in Europe about this kind of infrastructures. I mean, about digital humanities and about language technologies. So we started to work, and this is our roadmap. We started in 2016 with a project called Daria. That was funded by the Commission, and Daria was participating in this project. In 2018, we built a strategic network. That means that the government of Spain considered that the adhesion of Spain to these two ERICs, or strategic, infrastructures, was strategic for the government. So they give us funds to start to build a bigger ecosystem about these issues. And in 2022, we continue the work of Intele with a new strategic network. We changed the name. It was CLARIA-S. And in 2023, Spain was adhered to the Daria and Clarin infrastructure. So in the same year, CLARIA-S was starting to work. So I don't know, you know what is Daria and Clarin? Because I'm talking about Daria and Clarin, you don't know what is this? No? Okay, I'm going to try to introduce what is these infrastructures. Okay, so CLARIA is a national research infrastructure and it's a strategic network. We use the strategic network as a vehicle to get funds from the government and to build a national research infrastructure, okay? This is the point, because Spain, the government of Spain need enough people who has interest in these issues to build to finance the network. So what we understand as an infrastructure is that it has three pillars. One is get knowledge from our colleagues and share knowledge. Second, have and share hardware for building everything that we want to do. And people. People is the most important thing in infrastructure like this, in CLARIA-S, that allow us just making it working, and of course to get options for getting budget for projects. So this infrastructure is based in the FAIR principles. I know that everyone knows about this. Findable, accessible, interoperable, and reusable, is meaning our research has to be fundable, accessible, interoperable, and reusable. I think that is everybody knows that. Yes or not? Yes, okay. Okay, so what more CLARIA is a digital infrastructure, because we have no buildings, we have anything that we can visit. Just only is digital. We have computers, we have servers, and people is what we have. And it's focused in digital humanities and language technologies. This is the point. This is because I didn't translate to Spanish to English, because I have to translate all the slides to Spanish to English for now. So it's an ecosystem for the research that has interest on these two fields, digital humanities and language technologies. Okay, so our mission is support and contribute to the national management and coordination of the European Research Infrastructure Consortia, CLARIN, that is focused on data and digital process related to language, and Daria, focused on data and digital processes related to art and science studies. So this is our two pillars, CLARIN and Daria, that are the digital infrastructure, European digital infrastructure and they are both ethics. So now the map of CLARIA-S is this. We have 12 institutions that they are split around our territory. So we have institutions in Galicia, País Vasco, Catalonia, Andalusia, Madrid, and so on. We are split in our geography. And each one has resources that can share with all the community from digital humanities and language technologies. For example, the National Library is part of this consortium, and it has texts and collections. CLARIA CM is the joint of all the Madrid universities, public universities, that has different bibliographic resources, training, and language technology resources. CLARIA AN, that is from Andalusia, has resources for language technologies. EA Tex, this is another institution that is in Canary Island, so it's for preservation of applications and data. So they have servers. That's very important for us to have servers where we can put all our research and preserve it. So the other institution is CLARIA GAL, that is, has resources in Galician, in Galician language. CLARIA US, that is, has language resources in Euskera, in the Basque language. BCC is the Supercomputing Center of Barcelona that has hardware resources, and Skyle, that is the supercomputing service of Castilla and León, that as well as the same as BCC has computer resources. Finally, DialNet has bibliographic resources, and CSIC is the Consejo Superior de Investigaciones Científicas, has bibliographic and research resources. Cervantes Virtual as well has bibliographic. Tell me, because I heard it myself perfectly. Sorry. Okay, I'm going to try this. I know. Okay, CLARIA UNED, we have resources for research, training, and language technology. So, as you can see, we are 12 institutions, all devoted to digital humanities and language technologies. And our pillars are the Clarin and the Daria digital infrastructure, that are European infrastructure. Both of these infrastructure usually has more or less the same structure. They have a marketplace for reusable tool service. They have resources for education and training. They organize transnational and transdisciplinary working groups. And of course, they have a group for policy and forensic, just to influence in the commission to put in the map all these files. Okay. So the goals of our infrastructure are, one, in research, is to strengthen the infrastructure itself with data, services, tools, and success stories, research, communities, so on. Promote the sustainability and visibility of the results of national research projects, and promote the interdisciplinary in research. Dissemination, we want to enhance the visibility of the national research in the humanities at the European level, together with Clarin and Daria, and the rest of the European SHOC infrastructure, that is the open science infrastructure that are based in Europe. yeah. Regarding the networking, the idea is to increase opportunities for the national, European, and Ibero-American research and collaboration, increase financing and the possibility of obtaining projects in Europe, and interact with the industry, and promote the interaction with the agents of the new language economy that in Spain means all what is related with the use of artificial intelligence with the languages. Okay, finally, we have 4 work groups, 2 devoted to the language technologies, that is the B Center group and the Key Center group. These groups, or these centers, are structures that belongs to Clarín. So the idea is to build these structures in Spain for language technology resources. We have a work group in training with the goal of disseminate knowledge about digital humanities and language technologies. We have another group of communications, just for the dissemination, as I explained before. And finally, there is one group devoted to the area that is for all the digital humanities project and all the things related with digital humanities. This is the organization that we have now. We have just only 1 year, because it's a very, 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 very young infrastructure. We are starting. The idea is that we sum up a lot of institutions, more institutions, and that's the map that I showed you before. Instead of have only 12 institutions, maybe in 1 year we will be 20 or 50. This is the idea. That's all. I'm so sorry because I have to prepare in the last minute the presentation and everything. So sorry for the inconvenience, and I hope I explain well what is Claria is and what is the pillars and the objective of this infrastructure here in Spain. Thank you very much.
Gracias, Salvador. We'll have time to talk more this afternoon, right? And
yes, in Spanish.
Any questions? In Spanish? Or, yeah, okay. Any questions? ¿Alguna pregunta for Salvador? No? Okay. Thank you. Okay. And for a last presentation, una última presentación de la anfitriona, ¿no? The National Library of Spain. We have here our boss in the digital ecosystem of the National Library of Spain, Gloria Esposito, the head of the Digital Division and Processes. And she will share with you some thoughts on our vision, strategies, main areas of interest in our institution, and lines of action we are working on or we want to work on in the near future. Okay, so thank you, Gloria.
Okay, first of all, thank you for your interesting presentations. Sorry. I see that we share some similarities, but also many big differences in the work to develop AI. And from now on, I want to briefly outline the situation here in National Library of Spain. I promise I take only 10 or 15 minutes because I suppose you're hungry and you want to eat and take a beer, maybe. So unfortunately, we have not been able to develop very significant projects regarding AI. So I'm going to explain mainly our vision, strategy, and the problems we have detected. Firstly, we understand as AI strategy here in the library as those actions that using this technology help us to promote the use and reuse of our digital collections, offer better access to users and researchers, create knowledge experiences and deeper insights into the collections, and not as interesting but very important for us, automate and enhance internal processes and workflows. In terms of AI, given that this technology has been developed very recently, I think that it's very important to set the legal framework, especially here in Spain, because we have not a very strong framework to develop the AI and to provide access to our data. So first of all, here, as you know, we have a European directive that establishes an exception for text and data mining for research purposes. Unfortunately, it has been not transposed entirely or clearly into our national law due to copyright issues. So it's not been effectively applied here in Spain. So the BNE does not provide accesses for the data due to this reason. It was enacted before the rise of generative AI, so it doesn't distinguish between ingestion, use, or generation, and it leads to some problems we are trying to face here in Spain. The other regulation provides very harmonized AI standards and classifies AI systems according to their risk. It mentions more or less the compliance with copyright rights, but it is not also very clarifying. And as I said, here in Spain, we have not a strong regulation regarding the AI, but we have a royal decree that sets also the exceptions for text and data mining. Another one that addresses the national authority for AI supervisor, allow that sets testing framework for specific high-risk systems, but this law has not been carried out yet. And finally, this is we have a very ambitious and comprehensive AI statal strategy, but it outlines objectives without detailing a lot how to achieve them, or the tools to use, or the budgets, or the partnerships involved. So it's not very helpful actually. At this point, and regarding the AI here in National Library of Spain, we have to ask ourselves two questions. One of them is, what can the BNE do to promote the development of AI here in Spain, and how can the BNE benefit from the development of AI in Spanish? The answer for the first question lies on the vast amount of data in Spanish we have here housed in our library by means of our digital collections. These collections consist mainly on digitized physical collections, electronic legal deposit, which includes preprints of works submitted by legal deposit, Spanish web archive, and digital born works. Those collections are mainly text, but also audio and images. The size is about 6 or 7 petabytes. From 2 of them are related to the web archive. The access, obviously, is very important to training and development the LLM. Okay. Regarding the second question, numerous potential projects could be developed, from some of them modest to other ones more ambitious. But however, given our resources, our staffing, we have only addressed the following so far. The first of one is the automated cataloging from preprint submitted through the legal deposits. We have analyzed, well, in fact, we are analyzing two paths. One of them is using a process created with Power Automate or similar automatization tools, and ChatGPT or any similar AI tool that performs cataloging directly. In this case, we have to be very careful with the copyright, because obviously it's not legal to feed ChatGPT or a commercial AI tool with data protected by copyright. The other way is using ALMA. ALMA is our integrated library management system. We have migrated from the previous one to ALMA just this year, and it provides some functionalities that permits the enhancement of the data and also the automatic cataloging. So we are investigating whether these systems can catalog from the first 5 or 6 pages of a work in order to avoid the problems with the copyright. Two interesting projects we are intent to develop throughout next year are transcription of manuscripts and audio files and automatic generation of EPUBs from digital works. We believe that we will implement automatic processes for this year, but we are in our way. We previously collaborated with some university groups to develop AI for transcribing manuscripts. They work quite well, but newer tools have been developed, so we are going to investigate them because they show to have better performances. Regarding the image recognition and collection enhancement, we performed a pilot. It was carried out by Elena 2 years ago, and it was successful, but again, the technology has improved a lot, and we intend to address a new project. With this, our intention is to enrich and enhance the user experience, visiting the digital collections, and improving and extending the information we provide them. Then we have the authorship assignment to anonymous works via stylometry. This is one of my favorite ones, because the BNE has already collaborated with a project named, it's like in English, Golden Century Stylometry, more or less, thanks to which an anonymous work was identified, and it was discovered that it belonged to Lope de Vega. So I think it's quite interesting, and the idea is to apply AI with stylometric criteria to identify new works in the future. Another project which is not as interesting but very necessary here in our library is related to internal processes and workflow automation. Why? Because there are many processes here in BNE, including tasks that don't provide a real value, but takes up a lot of time and resources in terms of money and personnel. So we are looking at ways to automate processes using AI to save time and cost, as well as using staff for other more valuable tasks. Lately, the assistance chatbots, I think that is very common to find chatbots in every web page, but we have not implemented yet in our website. So we're going to implement a help chatbot in our website, feeding it with the most common and frequently asked questions, doubts, and description of the BNE services, so that it works like a personal assistant in terms of help the user to find someone in the web or inform about any services of any procedures that we provide here at BNE. Okay, having said that, we must admit that we have many challenges ahead to successfully carry out these projects, and maybe in the future other more ambitious. But at the same time, there are development and improvement opportunities like never before. Some key concepts that come to my mind when I think about challenges and opportunities in terms of AA are copyright, size of digital collection, because our collection is huge, AI national strategy, which is a must, energy and environmental cost and sustainability. I want to remark this issue. Technical and human resources, AI development, and processes automation. Of course, the most obvious opportunity is directly to develop the AI projects. However, there are some issues that we have to address, such as training and capacity of the staff. The global strategy, it must be a priority, establish a global strategy here in Spain, both in the state and institutional level. Then resources allocation, obviously. The ability to evolve from pilot projects to full and real implementation of them. Promoting the digital literacy as a library. We have the authorize and we have the mandatory to do it. Ensuring that the elements in the language models or application we develop includes verification, analysis, and bias detection. Okay. Another significant challenge is obviously to get funding, because currently in the BNE we have not a dedicated budget to AI projects, and so far we have been relying on our ordinary budget, which changes every year, and it depends of which projects gets the money, and I mean, we depend on the other external institutions that wants to fund us. AI projects are expensive, involve costs that must be addressed, such as contracting equipment, licenses, storage system, preservation system, computing infrastructure. It is very important, specifically in those projects that involve the processing of a big amount of data. The maintenance of the equipment and the licensing, and technical training and consulting sometimes. Okay. This is one of my favorite challenges because I think that it's not always, but we used to forget to speak about it, and it's the environmental, sorry, because it's a very hard word for me to say in English, environmental impact that has the development of the AI. You have to think that the necessary infrastructure to develop the AI, specifically when you have to process a huge amount of data, involves very high energy consumption and very high cooling requirements. And these cooling requirements are usually solved by huge wet water usage. So for me, it's a pity and it's a problem. We have to face it. We must be conscious of this and design project in an efficient way, avoiding wasting resources, promoting the collaboration with other institutions, and promoting resources sharing and leveraging existing infrastructure. Okay. Another interesting challenge is that related with access. I think that Claria is very interested in this one specifically. The National Library of Spain and other national libraries have a digital collection that is like a gold mine for training language models and other forms of AI development. There is already, at least here in Spain, a significant demand for this data. However, as I said previously, the lack of regulation regarding access to copyright content, whether through the licensing or other ways, and the absence of formal procedure means that the BNE is not able to meet with this demand. We cannot provide access to the research organisms. At what point we consider offering data by process in a controlled environment here in the BNE, but we have not enough computing infrastructure for big projects. So, and additionally, no negotiations have been taking place with the owners of the copyright, And so we have not established access mechanisms. This situation is particularly challenging for the Web Archive because there is not a specific interlocutor to negotiate with. So we have to work in this way to be able to comply with the European regulation and with our own regulation and permit the accesses to the data. So, and this is all for now. I promise 10 minutes and that's all.
Hello? Yes. We almost made it on time. We are genius. I mean, thank you. Thank you all. Any question? Any last comment? No? Thank you, Gloria. We have an exciting way ahead. We want to do so many things. It's fascinating times, really. Okay, yes, we have a comment there, very far. Yeah.
It's just a comment about regarding the copyright that for me is one of the most frightening parts of the IA. We were talking about institutional consortia, but I think that maybe we have to get involved also editors because they have to be like a control also before the book get to us. They have to control the content of the books also. So I think it's important to count with them.
Sure. I bet many of you have comments on this. Yeah, thank you. Yeah. Would you like to share some thoughts?
I didn't hear to come up with?
To collaborate with editors. When we think about AI projects, of course, yes.
In our case, we started conversations with editors in order to set a kind of license to use the data. The problem is that editors has a part of the collection, but not the whole of it. So we have to keep conversation with more people and think strongly about the Web Archive, which is our main problem now.
Yeah, it's kind of a similar thing in Norway. Editors are for sure part of the conversation, but they are not the only players in the negotiation process, but they are part of it. They have to.
Any other thoughts? Any other? No? So thank you all our presenters today. Again, thank you also Peter, colleagues from the CNL for coming to Madrid. It's been inspiring. I mean, thank you for your inspiring work and for sharing that today with us, with our audience. I hope you have all enjoyed the morning, the people seeing us through YouTube also. And I hope to see you very soon with more beautiful projects from our beautiful institutions, right? Yeah, a lot of AI, and with more beautiful funding for our beautiful AI projects, right? Yes. Next time we invite the funders, and yeah. Okay, thanks again. Gracias a todos, de verdad. Espero que hayáis disfrutado también. Para nosotros es muy inspirador, es una conversación muy necesaria. They are our sister libraries, nuestras instituciones hermanas en Europa, y es una conversación absolutamente necesaria e inspiradora y muy importante para nosotros. Gracias por estar aquí. Thank you. Gracias.